Hi YouTube, Timothy Unkert here. This is a compilation of all the math problems that I recorded during the month of February. I'm going to label them by section. Hopefully you'll enjoy. Alright, in this problem we're dividing x cubed plus 2x squared minus 5x minus 6. We're dividing that by x plus 1. I'm going to set up the division here. So we got x cubed plus 2x squared minus 5x minus 6. We're dividing by x plus 1. I'm going to ask myself, what do I multiply x by to get x cubed? This is like x to the first power. So if I multiply it by x squared, well, x squared times x is x cubed. X squared times 1 is plus x squared. And now I'm going to subtract this like regular division. X cubed minus x cubed is 0. 2x squared minus 1x squared is just an x squared. We'll bring down the minus 5x minus 6. Then I think, what do I multiply x by to get x squared? Well, x times x, anything times itself is itself squared. So x times x is x squared. X times 1 is plus x. Then we subtract again. X squared minus x squared is 0. Negative 5x minus x is negative 6x. Bring down the minus 6. X times negative 6 is negative 6x. So negative 6 times x, negative 6x. And negative 6 times 1 is negative 6. Okay, so we're not going to have a remainder because we are subtracting something from itself. So we have 0 left over. So our solution here is x squared plus x minus 6. We can check that using a Punnett square if we want. So if we multiply the solution and the divisor together, we should get the dividend here. Okay? So I'm going to do a Punnett rectangle. So I have my solution x squared plus x minus 6 times x plus 1. X times x squared is x cubed. X times x is x squared. X times negative 6 is minus 6x. X squared times 1 is x squared. 1 times x is x. And 1 times negative 6 is negative 6. So we have x cubed plus 2x squared. Okay? Negative 6x plus x is negative 5x. So we've got that. And then we've got negative 6. So it all checks out. Okay, in this problem we've got x cubed minus 7x minus 6, and we're dividing by x plus 1. Notice we have no term with x squared in it here, so we're going to have to add that. So I'm going to divide x cubed plus 0x squared, so I'm adding the 0 for a placeholder, minus 7x minus 6, and we're dividing by x plus 1. So now we have to ask ourselves, what do I multiply x by to get x cubed? That's going to be x squared. X squared times x is x cubed. X squared times 1 is plus 1x squared. All right, so I'm going to subtract that. X cubed minus x cubed is 0. 0x squared minus an x squared is a negative x squared. Bring down the minus 7x. Bring down the minus 6 here. Now, x times negative x is going to give you negative x squared. Negative x times 1 is negative x. And we're going to subtract this off. Negative x squared minus negative x squared is 0. Negative 7x minus negative x is a negative 6x. And we'll bring down the minus 6 here. So we're going to multiply x by negative 6. So negative 6 times x is negative 6x. And negative 6 times 1 is negative 6. So we are subtracting something from itself, so we have no remainder. So x squared minus x minus 6 is our solution. Again, we can check this using the Punnett rectangle. So I have x squared minus x minus 6 multiplied by x plus 1. So x times x squared is x cubed. X times negative x is negative x squared. X times negative 6 is negative 6x. X squared times 1 is x squared. 1 times negative x is negative x. And 1 times negative 6 is negative 6. Notice the x squared and the negative x squared cancel out. We're left with x cubed minus 7x, because we have negative 6x and a negative 1x, minus 6. So we've got our dividend. Everything checks out. All right, in this problem, we've got x cubed plus 4x squared minus 3x plus 10. We're dividing by x plus 5. All right, so let's set up our division here. So we're going to ask ourselves, what do we multiply x by to get x cubed? Well, x squared times x gives you x cubed. X squared times 5 gives you plus 5x squared. And we'll subtract this off as we do in regular division. X cubed minus x cubed is 0. 4x squared minus 5x squared is a minus x squared. We'll bring down the minus 3x and the plus 10. X times negative x is going to be negative x squared. Negative x times 5 is a minus 5x. And negative x squared minus x squared is 0. Negative 3x minus a negative 5x is a positive 2x. Bring down the plus 10. X times 2 is going to be 2x. 2 times 5 is 10. Okay, so we have 2x plus 10 minus 2x plus 10, which is 0, so no remainder here. So our solution, our quotient, is x squared minus x plus 2. Now we can multiply the quotient and the divisor, and we should get the dividend as a check. So I'm going to do that with a Punnett rectangle. It's always good to check your work. So I have x squared minus x plus 2 and x plus 5. So x times x squared is x cubed. X times negative x is negative x squared. X times 2 is 2x. X squared times 5 is 5x squared. 5 times negative x is negative 5x. And 5 times 2 is 10. Okay, so we have x cubed. 5x squared minus x squared is 4x squared. Negative 5x plus 2x is negative 3x. And we have our 10 at the end there, and everything checks out. It's all good. All right, in this problem, we have 2x cubed minus 5x squared plus x plus 7, and we're dividing by x minus 2. So let's set up our long division. 2x cubed minus 5x squared plus x plus 7. We're dividing by x minus 2. If I multiply x by 2x squared, so 2x squared times x, I get 2x cubed. Now we also have to multiply 2x squared by negative 2. That's negative 4x squared. Okay, we're going to subtract this off just like we do in regular division. 2x cubed minus 2x cubed is 0. Negative 5x squared minus a negative 4x squared is going to be a negative x squared. We'll bring down the plus x and the plus 7. So if we do x times negative x times x, we get negative x squared. We also have to multiply negative x by negative 2. That's positive 2x. And subtract. Okay. X minus 2x is going to be a minus x. Bring down the plus 7. And if I multiply x by negative 1, I'm going to get negative x. Negative 1 times negative 2 is plus 2. So we will have 7 minus 2, a remainder of 5. So plus 5 over x minus 2. We can check this one. A good way to check this one would be synthetic division. So we got 2x cubed, negative 5x squared, 1x, 7. And we put a 2 on the outside here, so bring this down, 2. 2 times 2 is 4. Negative 5 plus 4 is negative 1. 2 times negative 1 is negative 2. 1 plus negative 2 is negative 1. And 2 times negative 1 is negative 2. We have the remainder of 5. Just like up there, we have 2x squared, a minus 1x, minus 1. So it all checks out. It's all good. All right, in this problem, we're dividing x to the fourth plus 3x cubed plus 6x squared plus 5x plus 3. And we're dividing it by x squared plus x plus 1. So x to the fourth plus 3x cubed plus 6x squared plus 5x plus 3. And we're dividing by x squared plus x plus 1. So if I multiply x squared by x squared, that'll give me x to the fourth. Now I have to multiply the x squared by the x here to get a plus x cubed, and x squared times 1 to get plus x squared. And like regular division, I'm going to subtract this stuff off. X to the fourth minus x to the fourth is 0. 3x cubed minus an x cubed is 2x cubed. 6x squared minus x squared is plus 5x squared. Bring down the plus 5x. And plus 3. Okay, now we want to think, what do I multiply x squared by to get 2x cubed? Well, plus 2x. 2x times x squared is going to give me 2x cubed. I have to multiply the 2x by x to get plus 2x squared, and the 2x times 1 to get plus 2x. And again, we're going to subtract. 2x cubed minus 2x cubed is 0. 5x squared minus 2x squared is 3x squared. 5 minus 2x is plus 3x. Bring down the plus 3. If I multiply x squared by 3, I get 3x squared. 3 times x is plus 3x. And 3 times 1 is plus 3. Okay, so if I multiply, or if I subtract anything by itself, I'm left with 0. So no remainder here. Now we could check these quickly. Let's see, we have time. Do a Punnett rectangle. So you're just going to multiply these together. I am doing this as a short, so I'll let you check those by multiplying them together. But yeah, that's pretty much it. Okay, in this problem, we've got x to the fourth plus 2x squared minus 8. We're dividing by x squared minus 2. We're going to have to add some placeholders here. So I'm going to have an x to the fourth. I'm going to add plus 0x cubed plus 2x squared plus 0x minus 8. And we're going to divide by x squared plus 0x minus 2. So x squared times x squared will give you x to the fourth. X squared times 0x is plus 0x cubed. X squared times negative 2 is negative 2x squared. And we are going to subtract this off here. X to the fourth minus x to the fourth is 0. 0x cubed minus 0x cubed is 0. 2x squared minus a negative 2x squared is 4x squared. Bring down the plus 0x minus 8. And we're going to multiply by 4. 4 times x squared. And then 4 times 0x. And 4 times negative 2. So we're not going to get, if we subtract something from itself, we're not going to get a remainder here. And our quotient, our solution here is going to be x squared plus 4. Okay, this problem we have 2x to the fourth minus x cubed plus 3x squared plus x minus 1 divided by x squared plus 1. So I'm going to make this x squared plus 0x plus 1 as our divisor. And we're dividing 2x to the fourth minus x cubed plus 3x squared plus x minus 1. So x squared times 2x squared That's going to give you 2x to the fourth. 2x squared times 0x is going to be 0x cubed. And 2x squared times 1 is plus 2x squared. We're going to subtract these. 2x to the fourth minus 2x to the fourth is 0. A minus x cubed minus 0x cubed is still minus x cubed. 3x squared minus 2x squared is plus x squared. We'll bring down the plus x and the minus 1. X squared times a negative x is going to give me a negative x cubed. Negative x times 0x is 0x squared. Negative x times 1 is negative x. And we're subtracting these. Negative x cubed minus negative x cubed is 0. X squared minus 0x squared is still x squared. X minus negative x is plus 2x. And we bring down the minus 1. And then if I multiply x squared by 1, I get x squared. We have plus 0x plus 1. So we subtract. X squared minus x squared is 0. 2x minus 0x is 2x. Negative 1 minus 1 is minus 2. So our remainder is going to be a plus 2x minus 2, and we'll write that over x squared plus 1. I don't need the 0x there. That's it for this one. All right, in this problem we've got x to the fourth plus 5x cubed plus 10x squared plus 10x plus 5, and we're dividing by x squared plus 2x plus 1. All right, so let's set up our division here. So x squared plus 2x plus 1, and we're dividing x to the fourth plus 5x cubed plus 10x squared plus 10x minus 5. Okay, so x squared times x squared, that'll give you x to the fourth. I also have to multiply the x squared by 2x, that's plus 2x cubed. And x squared times 1, that's plus x squared. Okay, we're going to subtract this off here. Okay, x to the fourth minus x to the fourth is 0. 5x cubed minus 2x cubed is 3x cubed. 10x minus x squared is plus 9x squared. We'll bring down the plus 10x and the minus 5. Now, x squared times 3x, that's going to give me the 3x cubed here. And then 3x times 2x is plus 6x squared. And then 3x times 1 is plus 3x. And again, we'll subtract this off here. 3x cubed minus 3x cubed is 0. 9x squared minus 6x squared is 3x squared. 10x minus 3x is plus 7x. And then we bring down the minus 5. Okay, we're going to multiply by 3 here. And we're going to get 3x squared. And then 3 times 2x is 6x. And then 3 times 1 is plus 3. And again, we'll subtract off. 3x squared minus 3x squared is 0. 7x minus 6x is x. Negative 5 minus 3 is minus 8. So our remainder is going to be x minus 8 over what we're dividing by x squared plus 2x plus 1. Okay, we've got x squared plus 7x plus 10. We're dividing that by x plus 2. Let's set this up. All right, so I've got my x squared plus 7x plus 10. I'm dividing by x plus 2. Now when I start this off, I want to think, what do I multiply x by to get x squared? Well, x times x gives me x squared. So x times x gives me x squared. But when I put the x up here, remember I have to multiply it by 2 as well. So I have to do x times 2, which is plus 2x. And then like regular division, I'm going to subtract this off. X squared minus x squared is 0. 7x minus 2x is 5x. So we have 5x plus 10. Then I think x times what gives me 5x? Well, x times 5 will give me 5x. And I also have to multiply the 5 by the 2. And in this particular problem, now that we subtract this off, we're subtracting 5x plus 10 from 5x plus 10. So we have a remainder of 0, and this is my solution. A couple ways you could check this. You could check this with synthetic division, or you could use a Punnett square and do x plus 2 times x plus 5. So x times x is x squared. X times 2 is 2x. 5 times x is 5x. And 5 times 2 is 10. Add these together, we get 7x. So you get back to the dividend, x squared plus 7x plus 10. All right, in this problem we have x squared minus 5x plus 6, and we're dividing by x minus 3. So we have x squared minus 5x plus 6. We're dividing by x minus 3. So I want to think to myself, what do I multiply x by to get x squared? The answer is x. So x times x is x squared. We also have to multiply x by this minus 3, so we have minus 3x here. And as with normal division, we're going to subtract this part off. X squared minus x squared is 0. Negative 5x minus a negative 3x is a negative 2x. We're going to bring down the plus 6. Then I think, what do I multiply x by to get negative 2? Well, the answer is minus 2. So negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. And this problem we also will have no remainder, because negative 2x plus 6 subtracted from negative 2x plus 6 is 0. So my solution here is x minus 2. Now to check this, we could do synthetic division, or we can do a nice little Punnett square, do x minus 2 times x minus 3. X times x is x squared. X times negative 2 is negative 2x. Negative 3 times x is negative 3x. And negative 3 times negative 2 is positive 6. So we get back to our dividend here, x squared. These two combine to be minus 5x plus the 6. All right, in this problem we have x squared plus 4x plus 9 divided by x plus 1. Let's set up the division. So I put my x squared plus 4x plus 9 here. We're dividing by x plus 1. And I've got to ask myself, what do I multiply x by to get x squared? Well, x times x will give me x squared, and x times 1 will give me plus 1x, right? Because we have to multiply the x by both the x and the 1. And now, like long division, we're going to subtract this off. X squared minus x squared is 0. 4x minus 1x is 3x. We'll bring down the plus 9. And then I want to ask myself, what am I going to multiply x by to get 3x? Well, if I multiply it by 3, 3 times x is 3x. I also have to multiply the 3 by the 1, so that gives me plus 3. And then I subtract. And this one will have a remainder. So 3x minus 3x is 0. 9 minus 3 is 6. So to write the remainder, we'll write plus 6 over x plus 1. If I wanted to check this with synthetic division, I can set it up. I have 1x squared, 4x, and 9. Negative 1 makes x plus 1 equal to 0, so I'm going to put a negative 1 on the outside. Bring down the 1. Negative 1 times 1 is negative 1. 4 plus negative 1 is 3. Negative 1 times 3 is negative 3. And 9 plus negative 3 is 6. We do have a remainder of 6, and we have x plus 3, so it does check out. All right, in this problem, we're dividing 2x squared plus 7x plus 3 by x plus 3. All right, so I'm going to set up my division. So I have 2x squared plus 7x plus 3, and we're dividing by x plus 3. I want to ask myself, what do I multiply x by to get 2x squared? The answer is 2x. So 2x times x is 2x squared. And I also have to multiply the 2x by 3. That's going to give me 6x. So we're now going to subtract this like regular long division. 2x squared minus 2x squared is 0. 7x minus 6x is just 1x. Bring down the plus 3. If I multiply x by 1, I get x. And 1 times 3 is plus 3. We're not going to have a remainder here, because when we subtract something from itself, the answer is 0. To check this, we could do Punnett square. So I have 2x plus 1 times x plus 3. And when I multiply this together, I should get 2x squared plus 7x plus 3. So x times 2x is 2x squared. X times 1 is 1x. 2x times 3 is 6x. And 3 times 1 is 3. You notice these two terms combine to give me my 7x, so it does all check out. All right, in this problem we have x cubed plus 3x squared minus 4x minus 12. All that's divided by x minus 2. Let's set up the division. So we have our x cubed plus 3x squared minus 4x minus 12. We're dividing by x minus 2. We want to think, what do I multiply x by to get x cubed? The answer is x squared, so x squared times x is x cubed. We also have to multiply x squared by negative 2, so we have negative 2x squared. Like normal long division, we'll subtract this off. 3x squared minus a negative 2x squared is like plus 2x squared, so that's 5x squared. Bring down the negative 4x and the negative 12. Now we think, what do we multiply x by to get 5x squared? The answer is 5x. So 5x times x is 5x squared. 5x times negative 2 is negative 10x. We're going to subtract this off. 5x squared minus 5x squared is 0. Negative 4x minus a negative 10x is like negative 4x plus 10x. That's 6x. Bring down the minus 12. I then think I need to multiply x by 6 to get 6x, so I'm going to put a plus 6 here. 6 times x is 6x. 6 times negative 2 is negative 12. 6x minus 12 subtracted from itself is just 0, so no remainder. Our solution is x squared plus 5x plus 6. If we did want to check this, we could check it by multiplying the polynomials together in a Punnett rectangle. So we've got x squared plus 5x plus 6 multiplied by x minus 2. We just multiply it out real quick. I'm doing this fast because this is a short video. Okay, so we get our minus 12, we get our x cubed. These two combine to be 3x squared, so we get that. And these two combine to be the negative 4x. So we get that. Everything checks out. In this problem, we're dividing x cubed plus 2x squared minus 5x plus 10, all that by x plus 3. Let's set up the division. So we've got x cubed plus 2x squared minus 5x plus 10. We're dividing by x plus 3. X times x squared is going to give me x cubed, so I got to write it x squared up here. And again, x squared times x is x cubed. X squared times 3 is plus 3x squared. We're going to subtract this off like normal long division. X cubed minus x cubed is 0. 2x squared minus 3x squared is a negative 1x squared. Then we'll bring down the minus 5x and the plus 10. If I multiply x by negative x, I'm going to get negative x squared. I also have to multiply this negative x by 3, so I get minus 3x, and we subtract off again. Negative x squared minus negative x squared is 0. Negative 5x minus a negative 3x is a negative 2x. Bring down the plus 10. X times negative 2 is going to give me negative 2x. And negative 2 times 3 is negative 6. Okay, so when I subtract this stuff off, this becomes 0, but 10 minus a negative 6 is like 10 plus 6. So we have a remainder of 16, which I can write as plus 16 over x plus 3. If I want to do a quick check with synthetic division, let's do that. So I've got 1x cubed, 2x squared, minus 5x, and 10. And if I put a negative 3 in here, that would be 0. So I'm going to bring down the 1. Negative 3 times 1 is negative 3. 2 plus negative 3 is negative 1. Negative 3 times negative 1 is positive 3. Negative 5 plus 3 is negative 2. Negative 3 times negative 2 is positive 6. So the remainder of 16, we have 1x squared minus 1x minus 2. So it all checks out. All right, in this problem we've got x cubed minus 6x squared plus 11x minus 6, and we're dividing by x minus 1. So I'm going to set up my division here. X cubed minus 6x squared plus 11x minus 6, and we're dividing by x minus 1. So first I want to ask myself, what do I multiply x by to get x cubed? Well, this is x to the first power. So if I multiply it by x squared times x will give me x cubed. I also have to multiply x squared times the minus 1 here, so we have minus 1 x squared. So now, just like normal division, I'm going to subtract off this stuff. So I have x cubed minus x cubed, that's 0. Here I have negative 6x squared minus a negative x squared, that's negative 5x squared. And I'm going to bring down the plus 11x and bring down the minus 6 here. Now I think, what am I going to multiply x by to get negative 5x squared? That's going to be a minus 5x. So minus 5x times x is minus 5x squared. We also do minus 5x times negative 1, that's plus 5x. Okay? We now subtract this off. Negative 5x squared minus 5x squared is 0. 11x minus 5x is 6x. And we bring down the minus 6 here. We now think, what do we multiply x by to get 6x? Well, x times 6, 6 times x gives you 6x. And we also multiply 6 times negative 1, that's minus 6. And you'll see here, we're not going to get a remainder because we're subtracting something from itself, so we're just left with 0. So our solution here is x squared minus 5x plus 6. Now you can check this with synthetic division if you want. And to do that, just set up our synthetic division. We have 1x cubed, negative 6x squared, 11x, and negative 6. And if I put in x as 1, 1 minus 1 equals 0. So I bring down the 1. 1 times 1 is 1. Negative 6 plus 1 is negative 5. 1 times negative 5 is negative 5. 11 plus negative 5 is 6. 1 times 6 is 6. And you see we have the remainder of 0. We have 1x squared, that matches, negative 5x, and 6. So it all checks out. All right, in this problem we have 2x cubed minus 4x squared plus 7x minus 5. We're dividing by x minus 2, so let's set up our division. So 2x cubed minus 4x squared plus 7x minus 5. We're dividing by x minus 2. So first off, I'm going to think, what do I multiply x by to get 2x cubed? Well, this is x to the first power. So if I multiply that by 2x squared, 2x squared times x is 2x cubed. I also have to multiply 2x squared times negative 2. That's going to be a minus 4x squared. Okay. Notice here we're subtracting something from itself. So we're just going to get 0 and 0, right? So now I'm going to bring down the 7x and the minus 5. And we're going to move to there. Okay, so what do I multiply x by to get 7x? Well, positive 7 or plus 7 here. So 7 times x is 7x. And then 7 times negative 2 is negative 14. We will have a remainder, so let's subtract. 7x minus 7x is 0, and negative 5 minus a negative 14 is going to be a positive 9. So we're going to write that as plus 9 over x minus 2. Okay, and we can check this with synthetic division if we'd like. So we have 2, negative 4, 7, negative 5, and we want to put a positive 2 on the outside here. We're going to bring this down, so 2 times 2 is 4, negative 4 plus 4 is 0. 2 times 0 is 0, 7 plus 0 is 7, 2 times 7 is 14, and we're left with a remainder of 9. We have 2x squared, 0x, plus 7, plus a remainder of 9, so it all checks out. All right, in this problem, we're going to divide x cubed minus 7x squared plus 14x minus 8 by x minus 4. So I'm going to set up my division here. So I've got x cubed minus 7x squared plus 14x minus 8, and we're dividing by x minus 4. So x times x squared will give me x cubed, and x squared times negative 4 is a minus 4x squared. And just with regular long division, we're going to subtract this part off. X cubed minus x cubed is 0. Negative 7x squared minus a negative 4x squared is a negative 3x squared. And now we're going to bring down the plus 14x and the minus 8. Okay, now we want to think, what do I multiply x by to get negative 3x squared? Well, if I multiply it by a minus 3x, so negative 3x times x is negative 3x squared. We have to multiply the negative 3x times the negative 4, that's plus 12x. And we subtract. Okay, 14x minus 12x is 2x. And we're bringing down the minus 8. And to multiply x to get 2x, we have to multiply by a positive 2. 2 times x is 2x. And 2 times negative 4 is negative 8. And we're subtracting the same thing from itself, so we don't have a remainder. So our solution here is x squared minus 3x plus 2. If you want to check this one, you can do either synthetic division or you could multiply using a Punnett rectangle. But that's pretty much it. All right, in this problem we have x cubed plus 5x squared minus 9. We're dividing that by x plus 3. I'm going to add a placeholder because we don't have a term with x in it in the dividend. So I'm going to write it as x cubed plus 5x squared plus 0x minus 9. We're dividing by x plus 3. So at first I ask myself, x times what gives me x cubed? Well, x times x squared will give me x cubed. We also have to multiply the x squared by 3, so we have plus 3x squared. And we're going to subtract this off. X cubed minus x cubed is 0, and we have 5x squared minus 3x squared, which is 2x squared. We're going to bring down the plus 0x and the minus 9 here. Then I want to think x times what gives me 2x squared? Well, x times 2x will give me 2x squared. So 2x times 3 is plus 6x. And then we're going to subtract this off. So 2x squared minus 2x squared is 0. And 0 minus 6x is a negative 6x. We're going to bring down the minus 9. Now I've got to think, what do I multiply x by to get negative 6x? Well, x times negative 6 is negative 6x, and negative 6 times 3 is negative 18. When I subtract this off, negative 6x minus negative 6x is 0. Negative 9 minus a negative 18 is a positive 9. So our remainder is 9, which we can write as plus 9 over x plus 3. In this next problem, we have 2x cubed minus 3x squared minus 11x plus 6, and we're dividing by x minus 3. So let's set up our division. So we have 2x cubed minus 3x squared minus 11x plus 6. We're dividing by x minus 3. So we have to ask ourselves, x times what gives me 2x cubed? Well, x times 2x squared will give me 2x cubed. And we also have to multiply the 2x squared by the minus 3, so that's going to be a minus 6x squared. And like regular division, we're going to subtract this off. 2x cubed minus 2x cubed is 0. And then we have negative 3x squared minus a negative 6x squared, which is going to give us a positive 3x squared. We'll bring down the minus 11x and the plus 6 here. We now have to ask ourselves, x times what gives us 3x squared? Well, x times 3x will give us 3x squared. We have to multiply the 3x by the minus 3. So that's a minus 9x. And we'll subtract this off. Negative 11x minus a negative 9x is a negative 2x. And we have plus 6. Now we have to ask ourselves, what do we multiply x by to get negative 2x? Well, negative 2. So negative 2 times x is negative 2x. And negative 2 times negative 3 is positive 6. So we can see here, since we're subtracting the same thing from itself, we have a remainder of 0. So our solution here is 2x squared plus 3x minus 2. All right, in this problem we have x cubed plus 4x squared plus 10 divided by x plus 2. Let's set up our division. So we have x plus 2, and we are dividing by that. We're dividing x cubed plus 4x squared. We have to add a placeholder because there is no term with x, so plus 0x plus 10. Okay, we have to ask ourselves, x times what gives me x cubed? Well, x times x squared will give me x cubed. And we have to multiply the x squared by 2. That's plus 2x squared. And we're going to subtract this off like regular long division. X cubed minus x cubed is 0. 4x squared minus 2x squared is 2x squared. We'll bring down the plus 0x and plus 10. Now I have to ask myself, what do I multiply x by to get 2x squared? Well, if I multiply x by 2x, that'll give me 2x squared. And 2x times 2 is 4x. And we subtract this off. 2x squared minus 2x squared is 0. And 0 minus 4x is a negative 4x. And we'll bring down the plus 10 here. And then I've got to ask myself, what do I multiply x by to get negative 4x? Well, negative 4. So negative 4 times x is negative 4x. And negative 4 times 2 is negative 8. And we'll subtract this off. Negative 4x minus negative 4x is 0. And 10 minus the negative 8 is positive 18. So that's our remainder. So we can write it as plus 18 over x plus 2. All right, in this problem we're taking x to the fourth plus 3x cubed minus 5x squared plus 10x plus 3, and we're dividing by the trinomial x squared plus 2x minus 1. So we're dividing by x squared plus 2x minus 1, and we are dividing x to the fourth plus 3x cubed minus 5x squared plus 10x plus 3. Okay, first off, we want to ask ourselves, what do I multiply x squared by to get x to the fourth? Well, x squared times x squared is x to the fourth. X squared times 2 is a positive 2x cubed. And x squared times minus 1 is a minus 1x squared. And as with regular division, we're going to subtract this part off. So x to the fourth minus x to the fourth is 0. 3x cubed minus 2x cubed is 1x cubed. And then negative 5x squared minus an x squared is minus 4x squared. And we want to bring down the plus 10x and the plus 3 here. Now I want to ask myself, what do I multiply x squared by to get an x cubed? Well, that's going to be plus x. So x times x squared is x cubed. X times 2x is plus 2x squared. And x times minus 1 is a minus x. And we subtract. X cubed minus x cubed is 0. Negative 4x squared minus 2x squared is a negative 6x squared. 10 minus a negative x is plus 11x. We bring down the plus 3. We then ask ourselves, what do we multiply x squared by to get negative 6x squared? Well, a negative 6. Negative 6 times x squared is negative 6x squared. Negative 6 times 2x is a negative 12x. And negative 6 times negative 1 is plus 6. We subtract. Negative 6x squared minus negative 6x squared is 0. 11x minus a negative 12x is 23x. And 3 minus 6 is minus 3. So our remainder is going to be plus 23x minus 3 over x squared plus 2x minus 1. And that's it. All right, in this next problem, we're taking x to the fourth minus 3x squared plus 5x minus 6, and we're dividing by x squared minus 2. So let's set up our division. We have x to the fourth, and actually, with the x squared minus 2, I should really write this as x squared plus 0x minus 2, just to have that placeholder. And here, I want to write plus 0x cubed, because I have no term with x cubed in it, and then minus 3x squared plus 5x minus 6. Okay? So we want to ask, what do I multiply x squared by to get x to the fourth? Well, x squared times x squared is x to the fourth. We also have to multiply the x squared by 0x, so plus 0x cubed, and the x squared by negative 2, so that's minus 2x squared. And as with regular division, we subtract off. X to the fourth minus x to the fourth is 0. 0 minus 0 is 0. Negative 3x squared minus 2x squared is going to be a negative x squared. And we'll bring down the plus 5x and the minus 6. Now if I multiply x squared by negative 1, I'm going to get negative x squared. Negative 1 times 0 is plus 0x. And then negative 1 times negative 2 is plus 2. And we'll subtract off. Negative x squared minus negative x squared is 0. 5x minus 0 is 5x. And negative 6 minus 2 is minus 8. So our remainder is 5x minus 8. We'll write it as 5x minus 8 over x squared minus 2. And that's that one. All right, in this problem, we're taking 2x to the fourth plus 5x cubed plus x squared minus 7x minus 12, and we're dividing that by x squared plus 2x plus 3. Okay, so I'm just going to set up the division here. So we have 2x to the fourth plus 5x cubed plus x squared minus 7x minus 12. And we got to ask ourselves, what do I multiply x squared by to get 2x to the fourth? Well, 2x squared times x squared is 2x to the fourth. And then we multiply 2x squared by 2x, that's plus 4x cubed. And 2x squared times 3, that's plus 6x squared. And we're going to subtract this off. 2x to the fourth minus 2x to the fourth is 0. 5x cubed minus 4x cubed is just an x cubed. X squared minus 6x squared is minus 5x squared. We want to bring down the minus 7x and the minus 12. And then we think, what do we multiply x squared by to get x cubed? Well, that's plus x. So x times x squared is x cubed. X times 2x is plus 2x squared. And x times 3 is plus 3x. Okay, and we subtract off. X cubed minus x cubed is 0. Negative 5x squared minus 2x squared is a minus 7x squared. Negative 7x minus 3x is minus 10x. And we bring down the minus 12 here. Now if I multiply x squared by negative 7, that's going to give me negative 7x squared. Negative 7 times 2x is a negative 14x. And negative 7 times 3 is a minus 21. And we're going to subtract this off. Negative 7x squared minus negative 7x squared is 0. Negative 10x minus negative 4x, or 14x, is a positive 4x. Negative 12 minus negative 21 is a positive 9. So our remainder now is 4x plus 9 because we can't multiply, well, because our lead coefficient has a power of 2 and this is the first power. So I'm going to write my remainder is plus 4x plus 9 over what we're dividing by, x squared plus 2x plus 3. All right, in this problem we've got x to the fourth plus 2x cubed minus 3x plus 5, and we're dividing by x squared plus x plus 1. Okay, so let's set up our division. So we have x squared plus x plus 1, and we are dividing x to the fourth plus 2x cubed. I have no term with x squared, so I'm going to add a plus 0x squared minus 3x plus 5. And then I think, what do I multiply x squared by to get x to the fourth? Well, x squared times x squared is x to the fourth. X squared times x is plus x cubed. X squared times 1 is plus x squared. And as with regular long division, we'll subtract this off. X to the fourth minus x to the fourth is 0. 2x cubed minus an x cubed is 1x cubed. And 0x squared minus x squared is minus x squared. Bring down the minus 3x and the plus 5. And now, what do I need to multiply x squared by to get x cubed? Well, it's plus x. So x times x squared is x cubed. X times x is plus x squared. And x times 1 is plus x. And again, we're going to subtract this off. X cubed minus x cubed is 0. Negative x squared minus an x squared is minus 2x squared. Negative 3x minus x is minus 4x. And then we have plus 5. Then I want to think, what do I multiply x squared by to get negative 2x squared? Well, negative 2 times x squared is negative 2x squared. Negative 2 times x is negative 2x. And negative 2 times 1 is negative 2. And we're going to subtract this off. Negative 2x squared minus negative 2x squared is 0. Negative 4x squared minus a negative 2x squared is a negative 2x. Sorry, negative 4x minus a negative 2x is a negative 2x. And then 5 minus a negative 2 is like 5 plus 2. So our remainder is negative 2x plus 7. So sometimes we can write it, like if I wanted to write it with a plus, I could write plus 7 minus 2x over x squared plus x plus 1. I could also write, you know, the topic, write negative 2x plus 7. But I don't know. That's a neat way to write it. Anyways, that's it for this problem. All right, in this problem we have 2x squared plus 7x plus 3 divided by x plus 3. So let's set up our long division here. So we have 2x squared plus 7x plus 3, and we're dividing by x plus 3. So when I do this polynomial long division, what I want to ask myself is, what am I going to multiply x by to get 2x squared? Well, x times x is x squared, and we have to have a 2, So this is like 1x, so we have to multiply by 2x. Okay, so 2x times x gives me 2x squared. We also have to multiply the 2x by 3, so 2x times 3 is 6x. And then we subtract off this product here of 2x and x plus 3 from 2x squared plus 7x plus 3. Okay, so 2x squared minus 2x squared is 0. 7x minus 6x is 1x. And we're going to bring down the plus 3 here. Then I ask myself, what do I multiply x by to get x? Well, anything times 1 is itself, so I'm going to multiply by 1. So 1 times x is x, and 1 times 3 is 3. And now we're subtracting x plus 3 from x plus 3, which leaves a remainder of 0, so 2x plus 1 is my solution. Okay, in this problem we have 3x squared minus 10x minus 8, and we're dividing by x minus 4. So we're going to set up our long division. Again, we have 3x squared minus 10x minus 8, and we're dividing by x minus 4. So we first want to ask ourselves, x times what gives me 3x squared? Well, this is 1x, so 1 times 3 will give me the 3, and then x times x gives me x squared. So then we take this 3x and we multiply it by x to get 3x squared, and we multiply it by a minus 4 to get a minus 12x. Okay? Now what we do is we're going to subtract this product off of 3x squared minus 10x minus 8. So 3x squared minus 3x squared is 0. Now we have to be a little careful here because we have a negative 10x minus a negative 12x, which is like negative 10x plus positive 12x. So we actually get 2x, and then we bring down minus 8 here. So now we want to ask ourselves, x times what gives me 2x? Well, x times 2 will give me 2x, and 2 times negative 4 is negative 8. Okay, so we have 2x minus 8 minus 2x minus 8, which leaves a remainder of 0. So my solution for this one is 3x plus 2. Okay, in this one we have x cubed minus 8 divided by x minus 2. Now we've got to be careful here when we write the dividend because we want to add the placeholder. So we're going to start with x cubed, but then we add a placeholder because there's 0x squared, and another placeholder because there's 0x, and then the minus 8. And we're dividing by x minus 2. So then I ask myself, what do I multiply x by to get x cubed? Well, x is like x to the first power, so I'm going to multiply x by x squared, because we add the exponents when they have the same base and we're multiplying. So x squared times x is x cubed. And we also multiply x squared by negative 2, which is negative 2x squared. And then we subtract this product off of the dividend. So we do x cubed minus x cubed is 0. Then we do 0x squared minus a negative 2x squared, which is just a positive 2x squared. Because when we're subtracting a negative, it's like adding a positive. We bring down the plus 0x and the minus 8. Next up, we ask, what do we multiply x by to get 2x squared? Well, we have 1x, so we have to multiply it by 2x, because x times x gives me x squared. So 2x times x is 2x squared. 2x times negative 2 is minus 4x. And again, we subtract off. So 2x squared minus 2x squared is 0. 0 minus a negative 4x is like 0 plus 4x. So we have 4x, and we bring down minus 8 here. And then we ask, what do I multiply x by to get 4x? Well, 4. 4 times x is 4x. And 4 times negative 2 is negative 8. So we have 4x minus 8, minus 4x minus 8, which leaves a remainder of 0. And our solution is x squared plus 2x plus 4. Okay, in this problem we have 2x squared minus 5x minus 1. We're dividing that by x minus 3. I've set up the division here, so we have 2x squared minus 5x minus 1 divided by x minus 3. our first question is, what do I multiply x by to get 2x squared? Well, this is 1x, so we have to multiply by 2, and then x times x is x squared. So 2x times x is 2x squared. 2x times a negative 3 is a minus 6x. And we're going to subtract this now off. So 2x squared minus 2x squared is 0. Then we have negative 5x minus a negative 6x, which is like negative 5x plus 6x. So we have 1x. Bring down minus 1 here. Now I think, what do I multiply by x to get x? Well, if I multiply x by 1, I get x. So 1 times x is x, and 1 times minus 3 is minus 3. Now we're subtracting this here from x minus 1. So x minus x is 0, and negative 1 minus a negative 3 is like negative 1 plus 3. So we get 2 as a remainder. So we can write that as plus 2 over what we're dividing by, x minus 3. And my solution is 2x plus 1 plus 2 over x minus 3. Okay, in this problem we're going to use the remainder theorem to find the remainder of x cubed minus 4x squared plus 5x plus 3 divided by x minus 2. So what we're going to do is we're going to take the opposite of the sign. So we're going to take positive 2 and put this in for x in the dividend here, and that's going to give us the remainder. So I'm going to do 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. 2 cubed is 2 times 2 times 2, that's 8. Minus 4 times 2 squared is 2 times 2, that's 4. So minus 4 times 4. Plus 5 times 10 is 10, plus 3. 4 times 4 is 16, so we have 8 minus 16. 10 plus 3 is 13, so plus 13. So we have negative 8 plus 13, so our remainder is positive 5. Okay, we're going to use the remainder theorem to find the remainder of 2x to the fourth minus 3x squared plus 7x minus 5. That's our dividend divided by our divisor, x plus 2. So I'm going to take the opposite of positive 2. I'm going to take negative 2 and put it in everywhere where x is. And if I put that everywhere where x is in the dividend, that'll give me the remainder. So I'm going to do 2 times negative 2 to the fourth power minus 3 times negative 2 squared plus 7 times negative 2 minus 5. So negative 2 to the fourth power is 4 negative 2's multiplied together. That's always going to be, when you raise a base to an even power, it's always going to be positive. So this is going to be positive 16, so it's going to be 2 times 16 minus negative 2 squared is a positive 4. That's 3 times 4. 7 times negative 2 is negative 14, and then minus 5 here. 2 times 16 is 32, minus 3 times 4 is 12, plus negative 14 minus 5 is negative 19. 32 minus 12 is 20, plus negative 19, that's like 20 minus 19. So my remainder here is positive 1. Okay, problem 3, we're going to use the remainder theorem to find the remainder of the dividend, x to the fifth minus 1 divided by the divisor, x minus 1. So I'm going to take the number in the divisor, the minus 1 here, I'm going to change that to positive 1 and put that where x is here. So we're going to have 1 to the fifth power minus 1. 1 to the fifth power is 5 1's multiplied together, that's still 1. So 1 minus 1 is 0. So there is a remainder of 0, meaning that x minus 1 is a factor of x to the fifth minus 1. So in problem 4, we're going to use the remainder theorem to find the remainder. We have the quantity x to the 17th power minus 2x to the 12th power plus 7, and we're dividing that by the quantity x plus 1. So I'm going to take the number in the divisor, positive 1, I'm going to change that to a negative 1, and put that everywhere where x is in the dividend. So I'm going to have negative 1 to the 17th power minus 2 times negative 1 to the 12th power plus 7. A negative number raised to an odd power is always negative. And negative 1 times negative 1, that's 1 times negative 1 again, it's negative 1. So negative 1 to the 17th power is just plain old negative 1. A negative raised to a positive power is always positive. So we have minus 2 times positive 1 plus 7. So negative 1, 2 times positive 1 is 2. So I have negative 1 minus 2 plus 7. That's like negative 3 plus 7. So my remainder in this case is positive 4. Okay, problem 5 reads p of x equals 4x squared minus kx plus 7, and that leaves a remainder of negative 2 when divided by x minus 3. Find k. So negative 2 is the remainder, and if I change this from minus 3 to plus 3, put it in here, when I evaluate this side, it should equal negative 2. So I can set up an equation here. Negative 2 equals 4 times positive 3 squared minus k times 3 plus 7. And now I'm just going to solve for k. So 3 squared is 9, so negative 2 equals 4 times 9. K times 3 is 3k, so minus 3k plus 7. 4 times 9 is 36, so negative 2 equals 36 minus 3k plus 7. Let's combine 36 and 7, that's 43 minus 3k. That equals negative 2. I want to subtract 43 from both sides. So I'm going to get negative 45 equals negative 3k. Okay, so now to solve for k, I'm going to divide both sides by negative 3. Negative 45 divided by negative 3 is 15. So k is going to equal 15. All right, problem 6 reads p of x equals x cubed plus 3x squared plus ax minus 15, and it has a factor of x minus 3. Find a. So when a polynomial has a factor and you divide by that factor, you're going to get a remainder of 0. So I can say 0 equals, now instead of minus 3 here, we're going to put in positive 3 everywhere there's an x. So we're going to put in 3 cubed plus 3 times 3 squared plus a times 3 minus 15. Okay, so 3 cubed is 3 3's multiplied together, that's 27. Plus 3 times 3 squared is 3 times 3, that's 9. 3 times a, or a times 3 is 3a, and then minus 15. Okay, so 3 times 9 is also 27. So 27 plus 27 plus 3a minus 15. When I combine the like terms here, 27 plus 27 is 54. Minus 15 is 39, so we get 0 equals 39 plus 3a. Then I'm going to subtract 39 from both sides. So I'm going to get negative 39 equals 3a. And to solve for a, I'm going to divide both sides by 3. So we're going to get a is equal to negative 39 divided by 3, so a equals negative 13. Okay, problem 1. We've got x squared minus 5x plus 6, and we are dividing that by x minus 3. We want to know, what does that equal? So we're going to set up our long division here. So x squared minus 5x plus 6, that's divided by x minus 3. So first question we need to ask ourselves is, what are we going to multiply x by to get x squared? Well, anything times itself is that thing squared, so we have to multiply x by x. So x times x is x squared. X times negative 3, that's going to be a minus 3x. And we're going to subtract this off, like we do in regular long division. X squared minus x squared is 0. Negative 5x minus a negative 3x is a negative 2x. And we're going to bring down plus 6 here. Then we want to ask ourselves, what do we multiply x by to get negative 2x? Well, minus 2 times x is negative 2x. We also have to multiply this negative 2 times negative 3, and that gives us positive 6. And in this particular problem, we have a remainder of 0. Because we're subtracting the same thing from itself, so our solution here is x minus 2. All right, in problem 2, we've got 2x squared plus 7x minus 4, and we're dividing that by x plus 4. Okay, so we're going to put the 2x squared plus 7x minus 4. We're dividing by x plus 4. First question, what do I multiply x by to get 2x squared? This is 1. We have to multiply 1 by 2 to get 2, and x by x to get x squared. So 2x times x is 2x squared. 2x times 4 is plus 8x. And we subtract this part off. So 2x squared minus 2x squared is 0. 7x minus 8x is a minus 1x. And we bring down the minus 4 here. Next question, what do I multiply x by to get negative 1x? Well, minus 1. Minus 1 times x is negative 1x. And minus 1 times positive 4 is a minus 4. Again, we're subtracting the same thing from itself, so our remainder is 0, and our solution is 2x minus 1. All right, in our third problem, we've got x squared plus 6x plus 10, and we're dividing that by x plus 3. All right, so we're going to set up our long division. So we have x squared plus 6x plus 10. We're dividing by x plus 3. And we want to ask ourselves, what are we multiplying x by to get x squared? Well, x times x is going to give you x squared. And x times 3 is going to give you plus 3x. We're going to subtract these off. And we're going to get 6x minus 3x, which is just 3x. And bring down plus 10 here. Then I want to ask myself, what am I going to multiply x by to get 3x? Well, positive 3. So 3 times x is 3x. And 3 times 3 here is 9. So now, we're going to subtract these off. 3x minus 3x is 0. But 10 minus 9 is 1. So our remainder is 1. So we're going to write plus 1 over what we're dividing by, x plus 3. And that is our solution to this one. Problem 4. We've got 3x squared minus 8x plus 5. And we're dividing by x minus 2. All right, so let's set up our division here. 3x squared minus 8x plus 5. We're dividing by x minus 2. We want to ask ourselves, what do we multiply x by to get 3x squared? Well, x times 3x will give us 3x squared. We also need to multiply this 3x by minus 2. That's going to be a minus 6x. And we're going to subtract this off. 3x squared minus 3x squared is 0. A negative 8x minus a negative 6x is a minus 2x. And we'll bring down the plus 5. Next, I'm going to ask, what do I multiply x by to get negative 2x? That's going to be a minus 2. So minus 2 times x is negative 2x. And minus 2 times minus 2 is plus 4. If we subtract this off, we see that, well, negative 2x minus negative 2x is 0. 5 minus 4 is 1. So we also have a remainder of 1 here. So I'm going to write that as plus 1 over what we're dividing by, x minus 2. And this here is our solution. Okay, number 5. We've got x cubed plus 3x squared minus 4x minus 12, and we are dividing by x plus 3. So let's set up our division. So we have x cubed plus 3x squared minus 4x minus 12, dividing by x plus 3. So we have to ask ourselves, what do we multiply x by to get x cubed? Well, this is like x to the first. And when you're multiplying exponents with the same base, you add the exponent. So we actually have to multiply by x squared, because 1 plus 2 is 3. So x squared times x is x cubed. X squared times 3 is plus 3x squared. And now we subtract this off. You notice x cubed minus x cubed is 0, and 3x squared minus 3x squared is 0. So all we do is we just bring down the minus 4x and the minus 12. And then we ask ourselves, what do we multiply x by to get a negative 4x? Well, negative 4. So negative 4 times x is negative 4x, and negative 4 times 3 is negative 12. And when we subtract something from itself, well, we get a remainder of 0. So x squared minus 4 is the solution to this problem. Problem 6. We've got 2x cubed minus 5x squared minus 3x plus 7. And we are dividing by x minus 3. Okay, so let's set up our division. So we have 2x cubed minus 5x squared minus 3x plus 7. We're dividing by x minus 3. So we ask ourselves, what do we multiply x by to get 2x cubed? Well, it's 1x, so we're going to multiply 1 by 2. And remember, like the previous problem, x to the first power has to be multiplied by x squared to get x cubed. So 2x squared times x is 2x cubed. We also do 2x squared times minus 3, which is a minus 6x squared. And we subtract. 2x cubed minus 2x cubed is 0. And negative 5x squared minus a negative 6x squared is like negative 5x squared plus 6x squared. So that's a positive x squared. And then we bring down the minus 3x and the plus 7. Now we ask, what do we multiply x by to get x squared? Well, x times x will give us x squared. We also have to multiply the x by minus 3, so we have minus 3x. And we subtract that off. All we're left with is the 7 here, which is our remainder. So we're going to say plus 7 over x minus 3. And this is our solution. Problem 7. We've got x cubed plus x squared minus 10x plus 8, and we're dividing by x minus 2. So we'll set up our division here. So x cubed plus x squared minus 10x plus 8. We're dividing by x minus 2. We have to ask ourselves, what do we multiply x by to get x cubed? Well, again, x to the first times x squared gives you x cubed. X squared times minus 2 is a minus 2x squared. And we subtract. X cubed minus x cubed is 0. X squared minus a negative 2x squared is like 1x squared plus 2x squared. That gives us 3x squared. Bring down the minus 10x and the plus 8 here. Now we want to ask, what do we multiply x by to get 3x squared? Well, that's going to be plus 3x. So x times x gives you the x squared. So 3x times x is 3x squared. And 3x times minus 2 is minus 6x. And we subtract. So 3x squared minus 3x squared is 0. Negative 10x minus a negative 6x is a negative 4x. And we bring down the plus 8. Then we ask, what do I multiply x by to get negative 4x? Well, minus 4. Minus 4 times x is negative 4x. And minus 4 times negative 2 is positive 8. Because a negative times a negative is a positive. We subtract off, we have a remainder of 0. So x squared plus 3x minus 4 is our solution here. All right, here's our last problem today in this set. So we've got x cubed plus 5x squared plus 7x plus 2, and we're dividing by x plus 2. So we're going to set up our long division here. We've got x cubed plus 5x squared plus 7x plus 2. We're dividing by x plus 2. First question, what do I multiply x by to get x cubed? Well, I have to multiply by x squared. So x squared times x is x cubed. X squared times 2 is plus 2x squared. And we subtract this off. So we have x cubed minus x cubed. And then 5x squared minus 2x squared, which is 3x squared. Bring down the plus 7x and the plus 2 here. Then we ask, what do I multiply x by to get 3x squared? Well, plus 3x. So 3x times x is 3x squared. And we also do 3x times 2. That's plus 6x. And we subtract off. So 3x squared minus 3x squared is 0. 7x minus 6x is just 1x plus 2. So what do I multiply x by to get 1x? It's just 1. 1 times x is x. 1 times 2 is plus 2. We subtract this off and get our remainder of 0. So x squared plus 3x plus 1 is our solution to problem 8. And we are done with this problem set. All right, let's go through the honors problem set from today. So problem 1, we have that p of x equals x cubed minus kx squared plus 2x plus 7. And also states that the remainder is 19. When this is divided by x minus 3. And we want to find k. Okay, so what we're going to do is we're going to use the remainder theorem. So we can say that the remainder is 19 when it's divided by x minus 3. That means that a, the remainder theorem basically states that if you have some polynomial p of x, you divide that by a binomial x minus a, your remainder is p of a. So a in this case is 3. So everywhere there's an x, we're going to put a 3. And then we can use that to solve for k. So we have, instead of x cubed, 3 cubed minus k times 3 squared plus 2 times 3 plus 7. Okay, so 3 cubed is 3 times 3 times 3. So we have 19 equals 27. 3 squared is 9 minus 9 times k. 2 times 3 is 6 plus 6 plus 7. And now on the right-hand side of the equation, we can combine all the numbers. Those are like terms. So 27 plus 6 plus 7 is 40. So we have 19 equals 40 minus 9k. And then we're going to solve for k. We're going to subtract 40 from both sides. And we're going to get negative 21 equals negative 9k. And then what we're going to do is we're going to divide both sides by negative 9. The negative 9's cancel out. We're left with k equals negative 21 over 9. That can be simplified into a positive fraction. A negative divided by a negative is positive. So it can be simplified into 7 over 3. So k is equal to 7 over 3. So the first one. All right, problem 2. We're given a polynomial p of x equals 2 times x to the 4th power plus mx cubed minus 5x plus 2. And then it says the remainder is 4 when divided by x plus 2. And then we want to find m. Okay, so in this case, what we can do is our a is going to be, we're going to change the sign here because it's x minus a for the remainder theorem. So this is going to be a negative 2. We're going to put in everywhere for x. So we're going to say 4, that's the remainder, equals 2 times negative 2 to the 4th power plus m times negative 2 to the third power minus 5 times negative 2 plus 2. Okay, so let's work this out. So 4 equals 2. Negative 2 to the fourth power is going to be a positive 16. And when you put this in your calculator, if you're doing like a TI-83, you want to have the negative 2 in parentheses and the power of the exponent outside the parentheses. If you have negative 2 without the parentheses raised to the fourth power, it's like negative 1 times 2 to the fourth power. It's going to give you negative 16, which is incorrect for this particular case. Okay, so negative 2 cubed, raise a negative to an odd power, it's going to be negative. So that's going to be plus a negative 8 times m. And then we have like plus negative 5 times negative 2, so plus 10 plus 2. 2 times 16 is 32, so we get 4 equals 32. We can just say minus 8m plus 10 plus 2 is 12. We can combine our like terms on the right. So 32 plus 12 is 44 minus 8m. I'm going to subtract now 44 from both sides. And I'm going to get negative 42 equals negative 8m. And then, sorry, not negative 42, my mistake. Negative 40 equals negative 8m. And we're going to divide both sides by negative 8. Negative 40 divided by negative 8 is positive 5 equals m. So m equals 5 for this one. So problem 3, we're given the polynomial p of x equals x cubed plus ax squared plus bx minus 6. And x minus 1 and x plus 2 are both factors. And then it says, find A. Okay, so we have A and B that are the unknowns. When you have a factor, the remainder is 0. So we've got the number we're going to put in for x is 1 and negative 2. That'll give us 2 equations, and then we can eliminate the variable B to find A. Okay, so I'm going to say first equation 0 equals 1 cubed plus A times 1 squared plus B times 1 minus 6. 1 cubed is just 1, so 0 equals 1. 1 squared is 1 times A, so plus A. B times 1 is B minus 6. So we combine these, we get 0 equals negative 5 plus A plus B, and then we add 5 to both sides. One of our equations is 5 equals A plus B. Our other equation, we're going to put in negative 2. So we're going to say 0 equals negative 2 cubed plus A times negative 2 squared plus B times negative 2 minus 6. Okay. Negative 2 cubed is negative 8 plus negative 2 squared is 4 times A. That's going to be minus 2B minus 6. If we combine the like terms, negative 8 and negative 6, we get negative 14 plus 4A minus 2B. Add 14 to both sides. And we get 14 equals 4A minus 2B. I'm now going to take this first equation, and what I want to do is I want to multiply everything by 2. And I'll show you why in a moment. So 2 times 5 is 10, That's going to equal 2a plus 2b. The reason I did that is that I can add these two equations now, and that'll eliminate the b's. Excuse me. So we have 10 equals 2a plus 2b. We're going to add to that 14 equals 4a minus 2b. 2b minus 2b is 0, and then 2a plus 4a is 6a, and that equals 24. To solve for a, we just now divide both sides by 6, and we get that a is equal to 4. A equals 4, that one. All right, next one. Number 4, we have p of x equals kx cubed plus x squared minus kx plus 4. And the remainder is 10 when divided by x minus 2. Find k. All right, so we're going to plug in 2 for x everywhere, and remainder is 10. So 10 equals k times 2 cubed plus x squared minus k times 2 plus 4. So we get 10 equals 2 cubed is 2 times 2 times 2, that's 8. So 8k plus x squared minus 2k. Oh, we got to substitute in 2 for x, so that's going to be 2 squared. So that's going to be 4. So 8k plus 4 minus 2k plus 4 over here. Let's combine our like terms on the right-hand side. So we get 10 equals 8k minus 2k is 6k. 4 plus 4 is 8. So plus 8. And we're going to subtract 8 from both sides. 10 minus 8 is 2. 8 minus 8 is 0. So 2 equals 6k. To solve for k, we divide both sides by 6. And we get 1k equals 2 divided by 6 is the same as 1/3. So k equals 1/3. So number 5, p of x equals x cubed plus 3x squared minus kx plus 4. We don't need the semicolon just yet. Then and q of x equals 2x cubed minus kx squared plus 3x minus 2 not period. They have the same remainder. When divided by x minus 2. Find k. Okay. All right, so what we're going to do is we're going to put in 2 for x, and we're going to set each right-hand side of the polynomial equal to one another. So let's take the p of x first. I'm going to say 2 cubed plus 3 times 2 squared minus k times 2 plus 4 is going to equal, now we're going to take cube x, 2 times 2 cubed minus k times 2 squared plus 3 times 2 minus 2. And so we're going to work this all out to figure out what k is. So 2 cubed is 8 plus 2 squared is 4, so 3 times 4 minus 2k plus 4 equals 2 times 8 minus 2 squared is 4, so minus 4k plus 3 times 2 is 6 minus 2. Let's keep working this out. So we have 8 plus 12 minus 2k plus 4 equals 16 minus 4k plus 6 minus 2 is 4, so plus 4. We have 4 and 4 on both sides of the equation, so let's just get rid of that. Because if we subtracted 4 from both sides, we would get rid of that. And then let's combine like terms on the left-hand side, so we get 20 minus 2k equals 16 minus 4k. I like to keep k positive, or the coefficient in front of k positive, so I'm going to add 4k to both sides. So I'm going to get 20 plus 2k equals 16. I'm then going to subtract 20 from both sides. Minus 20 is 0, so we're left with 2k equals 16 minus 20, so 2k equals negative 4. Divide by 2, and we get k equals negative 2. Now keep in mind here that we could have added 2k, then we had a negative 2k over here equals 4, and we would have come up with k equals negative 2. What I meant when I said I like to keep the coefficient, the number in front of k positive, that's just something I do, but you don't have to. All right, that was number 5, and number 6 will be the last one we cover because 7 and 8 are bonuses. So 6, we've got p of x equals x to the 4th plus 2x cubed minus 3x squared plus ax plus b. The remainder is 6 when divided by x minus 1. And the remainder is 12 when divided by x plus 1. And then we want to find a and b. So this is going to create a system of equations again. And we'll use that to solve. So let's start with x minus 1. That means we're going to put a positive 1 in for x everywhere here. So we're going to say 6 equals 1 to the 4th plus 2 times 1 cubed minus 3 times 1 squared plus a times 1 plus b. Okay, so 1 to the 4th is just 1, so 6 equals 1 plus 2 times essentially 1, so plus 2 minus 3 times 1, so minus 3 plus a plus b. So 1 plus 2 is 3, minus 3 is 0, so we get 6 equals a plus b. That's one of our equations. So let's put that in maybe orange here or something. And it'll come back to it. Now let's pull this up and then just pull it right down like that. Okay, so next equation. So we got 12. And this time we're going to put in, because it's positive 1 here, we're going to put in negative 1 for x. So 12 equals negative 1 to the 4th power plus 2 times negative 1 cubed minus 3 times negative 1 squared plus a times negative 1 plus b. Okay, so 12 is going to equal, well, negative 1 to the 4th power is a positive 1. So negative number to an even power is positive. Negative number to an odd power is negative. So plus 2 times negative 1 minus 3 times positive 1 plus a negative a plus b. All right, so keep working this out. 12 equals 1, basically minus 2, minus 3, minus a plus b. So that's going to be negative 5, so it's going to be negative 4. So 12 equals negative 4 minus a plus b. If I add 4 to both sides, I get 16 equals negative a plus b. That's going to be the second equation that I want to use. And we can add these two, the 16 and the 6 equals a plus b, and the 16 equals negative a plus b. Eliminate a and then solve for b, and then use that to solve for a. So let's add them. Oops. Okay, so we got 6 equals a plus b. Let's add that to 16 equals negative a plus b. So if we add these, the a's cancel. We get 2b equals 6 plus 16, so 22. Divide by 2. And you get b equals 11. Okay, we can take this equation. So 6 equals a plus b. Now we know that b is 11. And then solve for a. So we're going to subtract 11 from both sides. So negative 5 equals a. So to summarize, a equals negative 5, b equals 11. And that's it for this problem set. Hopefully you enjoyed it. All right, for problem 1, we've got 5 times the quantity x minus 3 minus 2 times the quantity x plus 1 equals 4, and we want to solve for x. Okay, so what we're first going to do is we're going to distribute the 5 and the 2 on the left-hand side of the equation. So 5 times x, that will be 5x. 5 times negative 3 is negative 15. Then we do negative 2 times x, it's a minus 2x. And then negative 2 times 1, that's negative 2, and that equals 4. Okay, so now that we've distributed, we can combine our like terms. So if I combine 5x and I subtract 2x from that, we get a positive 3x. And then if I take negative 15 and subtract another 2, I get minus 17. And that equals 4. I can now solve for x by first adding 17 to both sides. Negative 17 plus 17 is 0, so we're left with 3x equals 4 plus 17, so 21. 3x equals 21. And then we want to divide both sides by 3. And we get x equals 7. Okay, so that's the first one. Problem 2, we've got 1/3 y plus 4 equals 5 sixth y minus 1, and we want to solve for y. Okay. So what I can do here is I can get rid of the fractions. I notice I have a denominator of 3 and a denominator of 6. Now if I multiply everything by 6, that's going to get rid of the fractions here. So if I do 6 times 1/3, I get 6/3 y. And then I do 6 times 4, let's get that arrow right, times 4 there, I get plus 24. It's going to be equal to, well then I'm going to do 6 times 5 6, so that's going to be 36 y. And then 6 times -1, which is minus 6. Now you say, well, I still have a fraction, but that's easy because now we can get rid of the fractions. 6 divided by 3 is 2, so we have 2y plus 24, and that equals 30 divided by 6, so that's 5y minus 6. And now I want to get the y's on one side of the equation, so I'm going to subtract 2y from both sides. 2y minus 2y is 0, so the left-hand side is only 24. And then we've got 5y minus 2y, which is 3y, minus 6. I then want to solve for y by adding 6 to both sides. So 24 plus 6 is 30, and -6 plus 6 is 0, so we're left with equals 3y. To solve for y, I can divide both sides by 3. And I'll get y equals 10. And that's our second one. And our third one, we've got 4k plus 3 times k minus the quantity k minus 2 equals 1/2 k plus 13.5. And we are going to solve this one. We're going to solve for k. Not for x, for k. Okay. So I can get rid of this fraction here if I just multiply this whole thing by 2. 3 over here. Multiply the whole thing by 2. If I do 2 times 4k, that's 8k. 2 times 3 times the quantity k minus 1, or k minus 2 rather, is going to be plus 6 times the quantity k minus 2. And then we're going to do 2 times 1/2, that's just 1k, which I can just write k. And then 2 times 13.5 is going to be plus 27. Okay, so now I want to distribute. So I've got 8k plus, then I'll do 6 times k, that's 6k. And then 6 times minus 2, so minus 12. That's going to equal k plus 27. Okay, on the left-hand side of the equation, I can combine 8k and 6k to 14k minus 12, and that equals k plus 27. I can now subtract 1k from both sides. So we get 14k minus k is 13k minus 12. K minus k is 0 equals 27. I can then add 12 to both sides. And I'm going to get 13k equals 27 plus 12, so equals 39. I can then divide by 13. and I'm going to get k is equal to 39 divided by 13 is 3. So k equals 3 for this particular problem. Problem 4. We've got 2 minus the quantity 3m minus 4 equals 3m plus 12, and we are going to solve for m. Okay. So this is like 2 minus 1 times the quantity 3m minus 4, so I'm going to distribute that negative 1. So I'm going to rewrite this as 2, and then we got minus 1 or negative 1 times 3m, so minus 3m. And then we've got the minus 1 times the negative 4, negative 1 times negative 4, so plus 4 equals 3m plus 12. On the left-hand side, we can combine 2 and 4. And 2 and 4 add to be 6, so we've got 6 minus 3m equals 3m plus 12. All right. Let's get the m's on one side, so if I add 3m to both sides, I like to keep the coefficient, the number in front of the variable, positive, and that's going to do this. So minus 3m plus 3m is 0. We're left with 6 equals 3m plus 3m, so 6m plus 12. And then I can subtract 12 from both sides. 6 minus 12 is negative 6. 12 minus 12 is 0, so we're left with negative 6 equals 6m. To solve for m from this point, I'm going to divide both sides by 6. And I'm going to get m equals negative 1. All right, for problem 5, we've got x plus 2 over 5 equals x minus 1 over 2. So with this one, we can cross multiply here. So if I do x plus 2 times 2, I'm going to rewrite that as 2 times the quantity x plus 2. And that's going to equal 5 times the quantity x minus 1. So 5 times the quantity x minus 1. All right, so we'll now distribute the 2 and the 5. So 2 times x is 2x. And then 2 times positive 2 is plus 4. And that equals 5 times x, which is 5x. And then 5 times the minus 1, the negative 1, so minus 5. Okay, let's get the x's on one side. So I'm going to subtract 2x on both sides. 2x minus 2x is 0. And we get just 4 equals 5x minus 2x, so 4 equals 3x minus 5. We're going to add 5 to both sides. And we get 9 equals 3x. And then to solve for x, we've got to divide both sides by 3. And so we get x equals 9 divided by 3, which is 3. So x equals 3. All right, now we're solving for x for that one. Last one, we've got 2w squared minus 10 equals 40. And we want to just find one value or one solution. You can enter either solution. I'm going to show you how to find both solutions, but find one solution to this. So first off, add 10 to both sides. So negative 10 plus 10 is 0. We get 2w squared equals 40 plus 10, which is 50. And then we're going to divide both sides by 2. 2 divided by 2 is 1, so we get 1 w squared equals 50 divided by 2, which is 25. Then we'll take the square root of all sides. We'll get w equals, we could have positive 5 or negative 5. So I'm going to write it like this. So positive 5, 5 times 5 equals 25, but also negative 5, because negative 5 times negative 5 equals a positive 25. So you could say w equals negative 5, and the other solution you can enter is w equals positive 5. GoPro, stop recording. Okay, so for problem 1, we've got x squared, we've got the polynomial x squared plus 4x plus 8, and we're dividing by x plus 1. We want to know what that is equal to. So we're going to set up our polynomial long division. So we've got x squared plus 4x plus 8. Dividing by x plus 1. So I want to know, what am I going to multiply x by to get x squared? Well, if I multiply x by x times x is x squared, and x times 1, we also have to multiply x by 1, so what we put up here has to multiply by both of these terms. So x times 1 is plus 1x. And then, as with regular long division, we're going to subtract off. So x squared minus x squared is 0. We don't need to write that. 4x minus 1x is 3x. And we're going to bring down the plus 8. Next, I want to ask myself, what do I multiply x by to get 3x? Well, I'm going to multiply it by 3. So plus 3. So 3 times x is 3x. And again, this 3 has to be multiplied by 1, so plus 3. And then we subtract that off. So 3x minus 3x is 0, but 8 minus 3 is 5. And so our remainder here is going to be plus 5 over what we're dividing by, which is x plus 1. Okay. So that was the first problem. On our second problem, we've got x squared minus 16, and we're dividing by x minus 4. Now note here, we go from x squared to just minus 16. We don't have a term with x in it. So we're going to have to add a placeholder. So we're going to have x squared, and then we're going to add our placeholder plus 0x, and then minus 16. And we're dividing by x minus 4. Okay, so we have to ask ourselves, what am I going to multiply by x to get x squared? Well, x times x times x is x squared. And remember, we multiply the x by the minus 4 as well. So x times negative 4 is negative 4x. And then here's where it gets a little tricky, because we are subtracting this off. So x squared minus x squared, that's easy, that's 0. But here we have 0x minus a negative 4x, which is like 0x plus a positive 4x. So we get 4x here, and then we bring down the minus 16. Then we ask ourselves, what do we multiply x by to get 4x? Well, positive 4. So 4 times x is 4x. We also have to multiply 4 by negative 4, so we get minus 16. And then we subtract that off. And 4x minus 16, if we take away 4x minus 16 from that, we're subtracting the same thing from itself, so we get a remainder of 0. So our solution is just x plus 4. Problem 3. Problem 3, we've got x cubed plus 4x squared minus 2x plus 5. And we're dividing that by x minus 1. And we want to see what that is equal to. Okay, so we got x cubed plus 4x squared minus 2x plus 5. And we're dividing by x minus 1. So we want to ask ourselves, what do I multiply x by to get x cubed? Well, let me just do it here. So x by itself is really, I gotta get that a little thicker. X is x to the first power, and if we multiply it by x to the second power, because we have the same base here, when you're multiplying, you add the exponent, so we get x cubed. So we want to multiply x by x squared. Okay? So we do x squared times x is x cubed. We also have to multiply x squared by the minus 1, so that's minus 1x squared. And then we subtract off. So x cubed minus x cubed is 0. 4x squared minus a negative 1x squared is like 4x squared plus positive 1x squared, so we get 5x squared. Bring down the minus 2x plus 5. And then we ask ourselves, what do we multiply x by to get 5x squared? Well, this is 1, so we have to multiply by 5. We have to do plus 5. And then we have to multiply x by x to get x squared. So 5x times x is 5x squared. 5x times negative 1 is a minus 5x. And we subtract off. So 5x squared minus 5x squared is 0. Negative 2x minus a negative 5x is like negative 2x plus a positive 5x, so we get a positive 3x, and we bring down the plus 5. Now we ask, what do we multiply x by to get 3x? Well, positive 3. So we do 3 times x is 3x, and then 3 times negative 1 is minus 3. And we subtract this last part off. 3x minus 3x is 0. 5 minus a negative 3 is like 5 plus a positive 3. So we have a remainder of 8. So we're going to write plus 8 over what we're dividing by, x minus 1. And this x squared plus 5x plus 3 plus 8 over x minus 1 is our solution for this particular problem. In problem 4, we've got x cubed minus 27. And we're going to have to add some placeholders to that. We're dividing by x minus 3. Okay. We've got x cubed, and then we're going to do add plus 0x squared plus 0x, so these placeholders are in red here, and then minus 27. We're dividing by x minus 3. Our first question, what do we multiply x by to get x cubed? Well, x times x squared, x times x squared will give you x cubed. We also have to multiply x squared by -3, so that's going to be a -3x squared. And then we're going to have to subtract this off. So x cubed minus x cubed is 0. 0x squared minus a -3x squared is like 0x squared plus positive 3x squared, so we get 3x squared plus 0x, and then minus 27. Okay, so then we ask ourselves, what do we multiply x by to get 3x squared? Well, if I multiply x by 3x, 3x times x is 3x squared. 3x times -3 is a minus 9x. And we're going to subtract this off. And so 3x squared minus 3x squared is 0. 0x minus a -9x is going to be like adding 9x. So we get 9x. Bring down the minus 27 here. Then we ask ourselves, what am I going to multiply x by to get 9x? Well, positive 9 plus 9. So 9 times x is 9x. And then 9 times -3 is minus 27. And hopefully you'll see here that we're subtracting the same thing from itself. So our remainder is 0. So x squared plus 3x plus 9 is our solution. All right, in problem 1, it says use the remainder theorem to find the remainder when p of x equals x cubed minus 4x squared plus 2x minus 5 and is divided by x minus 2. So we're going to change the sign here to a positive 2, put it in everywhere x is, and that's going to give us the remainder. So p of 2 will be our remainder, and that's going to equal 2 cubed minus 4 times 2 squared plus 2 times 2 minus 5. So 2 cubed is 8 minus 4 times 2 squared, which is 4, plus 2 times 2 is 4 minus 5. That equals 8 minus 4 times 4, which is 16, plus 4 minus 5 is -1. 8 minus 16 is -8 plus -1, so the remainder is -9. Okay, problem 2. Is x minus 4 a factor of p of x equals x cubed minus 5x squared plus 2x plus 8. All right, so if x minus 4 is a factor of this polynomial, when I put in 4 here for x, remember I'm going to change the sign, I should get p of 4 equal to 0. So let's see. So we're going to say P of 4 equals 4 cubed minus 5 times 4 squared plus 2 times 4 plus 8. So 4 cubed is 4 times 4 times 4, that's 64, minus 5 times 4 squared, so 5 times 16, plus 2 times 4 is 8, plus 8. So 64 minus 5 times 16 is 80, and 8 plus 8 is 16. So 64 minus 80 is negative 16 plus 16. That's going to equal 0. So the answer is going to be yes. X minus 4 is a factor of P of X. Okay, problem 3. Find K such that X minus 2 is a factor of P of X equals x cubed minus kx squared plus 4x minus 8. Okay, so for this to work, when I put in 2 for x, we want to get P of x equal to 0. And we're going to have to solve for k. So I'm going to say 0 equals, remember we changed the sign to positive 2, so 2 cubed minus k times 2 squared plus 4 times 2 minus 8. So 2 cubed is 2 times 2 times 2, that's 8, minus 2 squared is 4, so 4k. 4 times 2 is 8, plus 8 minus 8. So if we combine our like terms on the right-hand side, we have 8 plus 8, that's 16, minus 8 is back to 8. So we can say 0 equals negative 4k plus 8. Then to solve for k, I'm going to subtract 8 from both sides. So we get negative 8 equals negative 4k. I'm then going to divide both sides by negative 4. And so negative 4 divided by negative 4 is 1. So we get 1k, or k, equals negative 8 divided by negative 4, so positive 2. So k equals 2 is the answer to that one. And then number 4, if P of x equals x cubed plus 3x plus c, if that has a remainder of 10 when divided by x minus 1, find C. Okay, so we're going to say, well, we're going to put in a positive 1, so we're going to say 10 equals, and by that I mean put in a positive 1 for x, 10 equals 1 cubed plus 3 times 1 plus c. Well, 1 cubed is just 1 times 1 times 1, which is just 1. 3 times 1 is 3, plus c. If we combine our like terms, 1 plus 3 is 4. So we still have the plus c. And then to solve for c, we simply subtract 4 from both sides. And we get 6. 4 minus 4 is 0. 6 equals c. So C equals 6. That's our solution to that one. And we're dividing by x plus 5. All right, so we got 2x squared plus 7x minus 15 dividing by x plus 5. First question, what do I multiply by x to get 2x? Well, there's a 1 in front of here even though it's not written, so we have to do 1 times 2. And then if we multiply something by itself, we get that something squared. So we also have to multiply x by x. So 2x times x is 2x squared. And then we also have to multiply this 2x by the 5. So 2x times 5 is plus 10x. Now, as with regular long division, we're going to subtract off this here. So 2x squared minus 2x squared is 0. 7x minus 10x is a negative 3x. And then we're also bringing down the minus 15. Then we ask, what do we multiply x by to get minus 3x? Well, if we multiply x by negative 3, we'll get negative 3x. So negative 3 times x is negative 3x. And we also have to multiply negative 3 times 5, so that's negative 15. And we subtract. And since we're subtracting the same thing from itself, our remainder is 0. And 2x minus 3 is our solution. All right, problem 2. Problem 2, we've got x squared minus 8x plus 12. And we are dividing x minus 3. Or are we dividing by x minus 3? All right, so I'm going to set this up. We've got x squared minus 8x plus 12. We're dividing by x minus 3. First, we ask ourselves, what do we multiply x by to get x squared? Well, x times x is going to give me x squared. We also have to multiply this x by negative 3, so that's going to be a minus 3x. And we're going to subtract this part off. X squared minus x squared is 0. And then we have negative 8x minus negative 3x. That gives us a negative 5x. And then we'll bring down the plus 12 here. Next, we want to ask ourselves, what do I need to multiply x by to get negative 5x? Well, negative 5. Minus 5 up here. Negative 5 times x is negative 5x. And negative 5 times negative 3 is plus, or positive, 15. And we subtract this off. Now, negative 5x minus negative 5x is 0. 12 minus 15 is negative 3. So our remainder is negative 3, so I'm going to write minus 3 over what we're dividing by, x minus 3. Problem 3, we've got x squared minus 36. And we're dividing by x plus 6. Okay, so I'm going to have to add a placeholder here. So I have x squared. I have no term with x in it. So I'm going to put plus 0x. And then minus 36. And we're dividing by x plus 6. So then we ask ourselves, what do I multiply x by to get x squared? Well, I have to multiply by x. X times x is x squared. I also have to multiply x times 6, that's plus 6x. And we are going to subtract this off. X squared minus x squared is 0. 0x minus a positive 6x is a negative 6x. And we're going to bring down the minus 36. Then I ask myself, what do I multiply x by to get negative 6x? Well, I'm going to have to multiply by negative 6. So negative 6 times x is negative 6x. And negative 6 times positive 6 is negative 36. And when I subtract that off, I have a remainder of 0. So x minus 6 is my solution to number 3. Problem 4. We've got 3x squared plus 10x plus 4. And we're dividing by x plus 2. So we have 3x squared plus 10x plus 4 dividing by x plus 2. First question, what do I multiply x by to get 3x squared? Well, there's a 1 here, so 1 times 3 is going to be, thicken that up a bit, 1 times 3 is going to be the 3, and then we have to do x times x, so 3x. We do 3x times x is 3x squared, and then we have to do 3x times 2, which is positive 6x, and then we subtract this part off. Okay, so when we subtract off 3x squared minus 3x squared is 0. Then we do 10x minus 6x, which is 4x, plus 4. I have to think, what do I have to multiply x by to get 4x? Well, I have to multiply it by a positive 4. So 4 times x is 4x. And then 4 times 2, we have to do that as well, is plus 8. And we have to subtract this part off. So 4x minus 4x is 0. And then we have 4 minus 8, which is negative 4. Let's do that one in a different color. Negative 4. That's our remainder, so we're going to write that as minus 4 over what we're dividing by, which is x plus 2. And this here is my solution. Next one. All right, so the next one, we're doing a cubic divided by a binomial. So we're going to start with x cubed. So we've got x cubed plus 2x squared minus 5x minus 6. And we're dividing by x plus 3. Okay. So we have x cubed plus 2x squared minus 5x minus 6 dividing by x plus 3. First question, what do I multiply x by to get x cubed? Well, if I multiply x to the first power by x to the second power, it likes to switch me down apparently in this color, x to the second power, we're going to get x cubed. If I do x squared times 3, I'm going to have plus 3x squared. And I'm going to have to subtract this stuff off. So we have x cubed minus x cubed is 0. but 2x squared minus 3x squared is a negative 1x squared. I'm going to bring down the minus 5x and the minus 6. Then I ask, what do I multiply 1x by to get negative 1x squared? Well, I multiply it by negative 1x, or negative x. I don't have to write the 1. Let's do that. And let's do that in purple. So negative x. So negative x times x is negative 1x squared. Negative x times 3 is a negative 3x. And now we subtract this part off. Negative 1x squared minus negative 1x squared is 0. Negative 5x minus a negative 3x is a negative 2x. And we bring down the minus 6. Then I ask, what do I multiply x by to get negative 2x? Well, I'm going to have to multiply it by negative 2. So negative 2 times x is negative 2x. And negative 2 times 3 is negative 6. At this point, hopefully you'll see that we're going to have a remainder of 0 because we're subtracting the same thing from itself. So our solution here is x squared minus x minus 2. On to problem 6. Problem 6, we've got x cubed plus 5x minus 2, and we're dividing x minus 1 there. Or we're dividing by x minus 1. So we have x cubed plus 5x minus 2. We're dividing by x minus 1. We're going to think, what do I multiply x by to get x cubed? Well, if I multiply it by x squared, so x squared times x is x cubed. X squared times negative 1 is a negative 1x. And one thing that I didn't do, it's good I made this mistake, is I didn't add the placeholder. So let's do that. You can erase this stuff. If you're using a pencil, you can erase. So I should have a plus 0x squared. Notice we don't have a term with x squared in it. And then plus 5x minus 2. Okay, so if I do x squared times x, I get x cubed. X squared times negative 1 is a negative 1x squared. You notice I noticed my mistake is when I was lining up the terms, I noticed I wasn't lined up with like terms. I had an x and an x squared. Those are not like terms, so that I knew that wasn't going to work. So I knew I had to go back to the drawing board. And that's okay. Okay, so we have x cubed minus x cubed, that's 0. And then we have 0x squared minus a negative 1x squared, which is just 1x squared. And we bring down plus 5x, and then the minus 2. And then we want to think, what do I multiply x by to get 1x squared? Well, it's going to be 1x, which I can just write as plus x. So let's pick orange. Plus x. So we do x times x gives me the 1x squared. And then we do x times negative 1, and that's going to be a negative 1x. And we're going to subtract that off. 1x squared minus 1x squared is 0. And we have 5x minus the negative 1x, which is 6x. It's like 5x plus 1x. Bring down the minus 2 here. I want to think, what do I have to multiply x by to get 6x? Well, I have to multiply that by 6. So plus 6. So 6 times x is 6x. And then 6 times negative 1 is negative 6. And then we subtract that off. And 6x minus 6x is 0. Negative 2 minus negative 6 is like negative 2 plus 6. So we get positive 4. So we're going to write our remainder as plus 4 over what we're dividing by x minus 1. And our solution, solution is right here. Okay. Still recording? Good. Okay. Number 7. Problem 7. We've got 2x cubed minus 4x squared minus 10x plus 12. And we're dividing by x minus 3. Let's see what that equals. All right, so we got 2x cubed minus 4x squared minus 10x plus 12. Notice we go x to the third power, x to the second power, x to the first power, and then just the number. So I don't have to add a placeholder for this one. And we're dividing by x minus 3. So I'm going to ask myself, what do I multiply x by to get 2x cubed? Well, I have 1. I'm going to have to multiply it by 2. I don't like when it switches me down, so I have to multiply it by 2. And then x to the second power. Because this is x to the first power, this is x to the second power. When we multiply exponents with the same base, we add the exponents. So 2x squared times x is 2x cubed. And then we do 2x squared times negative 3, which is minus 6x squared. And we subtract off. 2x cubed minus 2x cubed is 0. Then we have negative 4x squared minus a negative 6x squared, which is like negative 4x squared plus 6x squared. So we get a positive 2x squared. And we bring down the minus 10x. And then we think, what do I multiply x by to get 2x squared? Well, we're going to have to do positive 2x. So 2x times x is 2x squared. And then 2x times negative 3 is minus 6x. And we subtract this stuff off. (2x squared minus 2x squared is 0. Negative 10x minus a negative 6x is a negative 4x. And we'll bring down plus 12. Then I ask, what do I have to multiply x by to get negative 4x? Well, I multiply by negative 4. Negative 4 times x is negative 4x. And negative 4 times negative 3 is a positive 12. So you note this one will have a remainder of 0. And we're left with 2x squared plus 2x minus 4 as our solution to number 7. Last one, we've got number 8, x cubed plus 27, and we're dividing by x plus 3. We want to see what that equals. We're going to have to add some placeholders here. So we have x cubed, but no term with x squared, so we have to do plus 0x squared, and then also plus 0x. So we have to go 3, 2, 1. And then we have plus 27. All right, and we're dividing by x plus 3. So I ask, what do I multiply x by to get x cubed? I multiply by x squared. X squared times x is x cubed. We do x squared times 3 is plus 3x squared. And then we subtract off. Zero x squared, well, x cubed minus x cubed is 0. 0x squared minus 3x squared is a negative 3x squared. Bring down the plus 0x and the plus 27. Then what do I multiply x by to get negative 3x squared? That's a negative 3x. Negative 3x times x is negative 3x squared. And negative 3x times 3 is negative 9x. Subtract this off. Negative 3x squared minus negative 3x squared is 0. 0 minus a negative 9x is like 0 plus 9x. So we have 9x, bring down plus 27. If I multiply x by 9, let's do a different color. X times 9, I get 9 times x is 9x, and 9 times 3 is 27. See, we're subtracting the same thing from itself. So this one has a remainder of 0, and x squared minus 3x plus 9 is our solution to number 8. Okay, in problem 1, it reads, use the remainder theorem. To find the remainder when p of x equals 2x cubed minus 5x squared plus 3x minus 10 is divided by x minus 3. All right, so for x, we're going to actually take the opposite of minus 3. We're going to take positive 3 and put it in there, and that will give me the remainder. So p of 3 will give me the remainder. So I say p of 3 equals 2 times 3 cubed minus 5 times 3 squared plus 3 times 3 minus 10. Well, 3 cubed is 3 times 3 times 3. That's 27. So this equals 2 times 27 minus 3 squared is 9, so 5 times 9. 3 times 3 is 9, so plus 9 minus 10. 2 times 27 is 54. 5 times 9 is 45. And then plus 9 minus 10 is negative 1. So this becomes 54 minus 45 is 9, plus negative 1, so my remainder is 8. Problem 2. If p of x equals x to the 4th minus kx squared plus 12, for what values of k will the remainder be 0 when divided by x minus 2? When p of x is divided by x minus 2. So for what value or values of k will the remainder be 0 when p of x is divided by x minus 2? Okay, so we're going to set p of x equal to 0. And if we're dividing by x minus 2, we're going to put in positive 2 for x, and then we'll solve for k. And it's probably going to be one value that works, not values. So we've got 2 to the 4th power minus k times 2 squared plus 12. Okay. 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. 2 squared is 4, so 16 minus 4k plus 12. We're going to add 16 and 12 together, so we get 0 equals 28 minus 4k. Okay, so I'm going to subtract 28 from both sides. I'll get negative 28. Put this up, negative 28. 28 minus 28 is 0, so equals negative 4k. And then I want to divide both sides by negative 4. So I get 7 equals k. So k equals 7 is my solution. One value that works there. Given that, x plus 1 is a factor of p of x equals x to the 15th power plus 1. What is the remainder when p of x is divided by x plus 1? Well, if x plus 1 is a factor, that means that the remainder is going to be 0. So 0 is the correct answer for this one. All right, number 4, a polynomial p of x is divided by x minus 5. If p of 5 equals negative 3, which statement must be true? Is it A, the remainder is 0? B, the remainder is negative 3. C, the remainder is 3. Or D, let's see, what do I have for D? X minus 5 is a factor of P of X. Okay, well, if x minus 5 were a factor of p of x, the remainder, when I put in 5, p of 5 would actually be 0. So it's not a factor, so we're going to cross off D and A. And the remainder, when I put in 5 for x, equals P of 5. So it has to be B. It's going to be, the remainder is negative 3. We don't change the sign just because we change the sign here. We don't change the sign there. So C doesn't work. So it's B. The remainder is negative 3. Okay, problem 5. Find the remainder of x cubed minus 2x squared plus 0x minus 4 divided by x plus 2 using the remainder theorem. So the remainder theorem states that the remainder of a polynomial p of x when divided by something like some binomial x minus a is p evaluated at a, p of a. So since it's x minus whatever a is, we have to have a negative 2 because x minus negative 2 would be x plus 2. So I'm going to put a negative 2 everywhere there's an x in here, and that's going to give me the remainder once I figure out what that number is. So we have negative 2 cubed minus 2 times negative 2 squared plus 0 times negative 2 minus 4. Negative 2 cubed is negative 8 because it's negative 2 times negative 2 times negative 2. Negative 2 squared is negative 2 times negative 2. That's a positive 4, so we have minus 2 times positive 4. 0 times anything is 0, so plus 0 minus 4. 2 times 4 is 8, so we have negative 8 minus 8. 0 plus negative 4 is just plus negative 4. Negative 8 minus 8 is negative 16 plus negative 4. So our remainder in this particular case is negative 20. So if p of x equals x cubed plus ax squared plus bx plus 6, and that has a remainder of 0 when divided by x minus 1, so x minus 1 is a factor, and a remainder of 0 when divided by x minus 2, which is also a factor, what is the value of a? Okay, so we can set up two equations here. Because we have two unknowns, a and b, and we have to eliminate one of those. So I can say 0. Now when I'm divided by x minus 1, I'm going to put in a positive 1 for x here. So I'm going to say 0 equals 1 cubed plus a times 1 squared plus b times 1 plus 6. Okay, so 1 cubed is 1. So I get 0 equals 1 plus 1 squared is 1 times a is just a plus a. B times 1 is b plus 6. So I get 0 equals combine 1 and 6, 7 plus a plus b. We can then subtract 7 to move it to the other side. So we can say negative 7 equals a plus b. And that's, I'm going to circle that in orange because that is one equation that is important. And then also when we divide this by x minus 2, we get 0. So that's our other equation that we're going to use. So we're going to say 0, and we're going to put in a positive 2 for x. So 0 equals 2 cubed plus a times 2 squared plus b times 2 plus 6. Okay, so 0 equals 2 cubed is 2 times 2 times 2, that's 8. 2 squared is 4 plus 4a plus 2b plus 6. Okay, combine 8 and 6, we get 0 equals 14 plus 4a plus 2b. Okay, we're going to subtract 14 from both sides. And 14 minus 14 is 0. We get negative 14 equals 4a plus 2b. And then I'm going to circle this equation because we want to use these to figure out what a is. Now, if I multiply this equation by negative 2, I will get negative 2b here. And if I add these, I can eliminate the b's and solve for a. So if I multiply everything in the top equation by 2, let's bring it down here. 2 times negative 7 is negative 14. That equals 2 times a, so 2a, plus 2 times b, 2b. And See, I'm getting tired because I said multiply it by -2. So this is going to be positive 14, negative 2a, and then minus 2b. Okay, so we're going to then add this to negative 14 equals 4a plus 2b. Now if I add these together, I get 0 equals negative 2a plus 4a. So 0 equals 2a. Negative 2b plus 2b is 0, so these cancel out. And divide by 2, I get a equals 0. And that's what they were asking. What is the value of a? So 7 says find the remainder when p of x equals x to the 100th power minus 2x to the 51st power plus 1, when that is divided by x minus 1. So in this case, a equals positive 1. So the remainder is going to be p of 1. So that's going to be 1 to the 100th power minus 2 times 1 to the 51st power plus 1. Well, positive 1 to any power is going to be 1. So this is going to be 1 minus 2 times 1 plus 1. Okay? So it's going to be 1 minus 2 plus 1. The remainder is going to be 0, which actually means that x minus 1 is a factor of x to the 100th power minus 2x to the 51st power plus 1. All right, problem 8, this one is a bit difficult. It says the polynomial p of x has the property that p of 4 equals 7 and p of negative 2 equals 1. What is the remainder when p of x is divided by x minus 4 times x plus 2? Okay, so this is a quadratic, right? So it's going to, if I were multiplying this together, it would be an x squared plus or minus something. But when we're dividing by an x squared, our remainder is going to have some kind of value times x plus some constant. It's going to be the power below is going to be, the power below x squared is going to be the remainder, where the remainder starts. So x to the first power. So our polynomial is going to be x minus 4 times x plus 2 times q of x, whatever the quotient is here, plus some ax plus b, whatever the remainder is there. So let's look at p of 4. If I put in p of 4, well, what's going to happen? We're going to have 4 minus 4 times x plus 2 times whatever the quotient of x is plus whatever a is times 4 plus b. And we know that p of 4 equals 7. We also know that 4 minus 4 is 0, and 0 times whatever this is times whatever this is going to be 0. So it's going to be 7 equals 0 plus then 4a plus b. So, 0 plus anything is that thing. So we have one equation. I'm just going to write 4a plus b on the left-hand side, but 4a plus b equals 7 is one of the equations. So I'm just going to circle that in a different color so that we know we want to come back to that. We also know that p evaluated at negative 2, that's going to be equal to negative 2 minus 4. I could have put the 4 in here as well, but anyways. Times negative 2 plus 2 times whatever the quotient is plus then a times negative 2 plus b. So this part here, circle it, this thing here is going to be 0. So we're going to have some negative 6 times 0 times whatever the quotient is. So long story short, it's going to be 0 plus negative 2a plus b. And we know that p of negative 2 is equal to 1. So we can say 1 equals 0 plus negative 2a, so minus 2a plus b. And 0 plus anything is itself, so we get 1 equals negative 2a plus b. Okay, so now we've got two equations here. We've got this one, and we can use those two equations to, we can add them together and eliminate a variable. So what I can do, especially if I multiply this equation by 2 and switch sides, so I'm going to switch sides here, so I'm going to say negative 4a plus 2b equals 2. And then if I add that to 4a plus b equals 7, well, now we can solve for b because negative 4a plus 4a, that's just 0. And then 2b plus b is 3b, which equals 2 plus 7, which is 9. So 3b equals 9. We'll divide by 3. And we'll get b is equal to 3. And now I know that 4a plus b equals 7. So 4a plus 3 equals 7. Subtract the 3. Oh, we're running out of room here. So 7 minus 3 is 4. So 4a equals 4. Divide by 4. A equals 1. So let me move over here. So a equals 1. B equals 3. Let's circle that. That's an important thing we need to know. So we're almost there. If I go back down here, notice that the remainder is a times x plus b. So a is 1, b is 3. So 1 times x, or 1x plus 3, is going to be our remainder when dividing by the quadratic. Okay, hopefully that makes sense. That one was a much harder one. That might be a bonus type one tomorrow. All right, so let's rewrite our equation here. So we have 3 times x minus 5 plus 4 equals 2x. And this is like plus negative 1 times 7 minus x here. Okay, so we're going to distribute the number in front of each of the parentheses and then combine like terms and solve for x. So we're going to do 3 times x, which is just 3x, and then 3 times minus 5, so minus 15. We have plus 4. That equals 2x. And then we're going to do plus negative 1 times 7, so that's negative 7. And then negative 1 times negative x is a positive x. Okay? Next up, we'll combine like terms. On the left-hand side, negative 15 and positive 4 combine to negative 11, so the left-hand side becomes 3x minus 11. On the right-hand side, we have 2x plus x, so that's 3x, and then plus negative 7. Now this is an interesting one because if I were to subtract 3x from both sides, 3x minus 3x is 0, so we have negative 11 on the left. Again, on the right, 3x minus 3x is 0. We have negative 7 on the right. So negative 11 cannot equal negative 7. So there is no solution here in this case. All right? So we can't say there's a value of x. There's no solution to that. Well, there's a couple different ways we could do this. We could figure out what x is quickly from the right-hand equation and then plug in what that is here and then solve for y. Or we could solve for 3y and then plug that in here, then find x, and then find y from that. So I think what I'm first going to do is solve for x in the right-hand equation. That seems a little quicker. So x equals negative, or x minus 3y equals 6. So if I add 3y to both sides, I'm going to get x equals 6 plus 3y. And then I'm going to take my value of x, this 6 plus 3y, and I'll substitute it in here for x. So I'm going to say 2 times 6 plus 3y plus 3y equals 12. And now I can solve for y. Do 2 times 6 is 12. 2 times 3y is plus 6y. Plus 3y equals 12. You might notice here that y is going to be 0. If I subtract 12 from both sides, I get 6y plus 3y equals 0. And if I combine my like terms here, I'm going to get 9y equals 0. But still, if I divide by 9, 0 divided by 9 is still 0. So y equals 0. Okay, number 3, what are the factors of x squared minus 7x plus 12? Well, when we're finding factors of quadratic, where the number in front of x squared is 1, there's a 1 here even if it's not written, what I can do is I can simply list the pair of factors that multiplies to 12, and then we're looking for the specific pair that adds to negative 7 as well. So if I start off and I do 1 times 12, well, that adds to positive 13. We want to add to a negative number, so let's try negative factors. So negative 1 times negative 12, that's negative 13, that's a bit off. Negative 2 times negative 6, again, multiplies to positive 12, adds to negative 8, a little bit closer. If I get to negative 3 and times negative 4, that multiplies to positive 12, and then adds to negative 7. So I'm going to select this pair, and I'm going to write the factored form as x minus 3 times x minus 4. So I took the negative 3, I put right here, took the negative 4, put it right here. And that's all there is to this one. All right, this problem, the line given by the equation y equals kx plus 5 passes through the point 2, 11. What is the value of the constant k? So tell us k is a constant here. And they give us an x and a y value. So I can say 11 equals k times 2 plus 5. And this is going to allow me to solve for k pretty quickly. So 11 equals k times 2 is 2k plus 5. We're then going to subtract 5 from both sides. And we're going to get 6 equals 2k. And from here, to solve for k, we're going to divide by 2. So k is equal to 6 divided by 2, which is 3. Okay, in problem 1, we have 2s minus 3t equals 10, and 6s minus 2t equals 16. And the question asks us, what is the ordered pair st that satisfies the system of equations above? Well, I would solve this via elimination. So what I would do is I would multiply negative 3 times everything in the top equation, get a new equation, and add that to the bottom one. So if we do that, negative 3 times 2s is negative 6s. Negative 3 times minus 3t is going to be a positive 9t. And negative 3 times 10 is going to be negative 30. We're going to add that to the bottom equation, which is 6s minus 2t equals 16. And what happens when we add these together, well, the negative 6s added to the positive 6s, they cancel each other out. because that adds to 0. And then we're left with 9t minus 2t, which is 7t, equals negative 30 plus 16, so negative 14. I can then divide both sides by positive 7. 7 divided by 7 is 1, so we get t equals negative 14 divided by 7, so t is negative 2. I can now take this value of t and I can put that back in where t is in either one of the equations. I'll pick the bottom one. And I'll solve for s. So let's say 6s minus 2 times the value of t, negative 2, equals 16. Well, negative 2 times negative 2 is positive 4. So we have 6s plus 4 equals 16. I'm then going to subtract 4 from both sides. 4 minus 4 is 0, so we're left with 6s equals 12. I can then divide both sides by 6. 6 divided by 6 is 1, so we get s equals 2. So s equals 2, t equals negative 2. We want to write this as an ordered pair. The ordered pair is st, so we have 2 first, and then negative 2. And this is our solution to that problem. So 2, negative 2. Next one, we have 3/5 x equals 6, and negative 2y plus 3/5 x equals 4. The question is, the system of equations has the solution xy. What is the value of y? So this is kind of a little trick they like to do on SAT-style questions. What we're going to do to answer this quickly is we're going to take the value of 3/5 x and substitute it in here. So I can rewrite that bottom equation to negative 2y plus 6 equals 4. And this allows me to solve for y very quickly. I can then subtract 6 from both sides. 6 minus 6 is 0, so we get negative 2y equals 4 minus 6, so negative 2. And then to solve for y, we just divide both sides by negative 2. Negative 2 divided by negative 2 is 1y, so y equals negative 2 divided by negative 2, y equals 1 is my solution to that one. Okay, in this next one we have 2w plus 2s equals 14, and 3w minus 2s equals 1. It says in the system of equations above, what is the value of w? Now you notice this is set up directly for elimination. So again, this top equation, we have plus 2s. Okay, in this bottom equation, we have minus 2s. So if we add these together, we will eliminate the s variable and we can solve very quickly for w. So 2s minus 2s is 0. These cancel out. We have 2w plus 2w, because remember, we're adding these. That's going to give me 5w equals 14 plus 1. So 5w equals 15. I can then quickly solve for w by dividing both sides by 5 and getting w equal to 3. In my last problem on the do now set, we've got y equals 3x and x minus y equals 14. It says for the given system of equations, what is the solution xy? So I'm going to start off by solving for x by just putting in 3x where y is. So the bottom equation becomes x minus 3x equals 14. 1x minus 3x is a negative 2x equals 14. To solve for x, I'm going to divide both sides by negative 2. And I'm going to get x equals negative 7. Okay. I've also got that y equals 3 times the value of x. So y is going to equal 3 times negative 7. So y equals negative 21. And we can write our solution as the coordinate pair with x first. So negative 7, negative 21 is our solution for this last problem. Okay, these are the college prep problems from February 18th, 2026. So problem 1 reads, if p of x equals x squared plus 3x plus 5 is divided by x minus 1, what is the remainder according to the remainder theorem? So we're going to evaluate this p of x at, well, essentially this is x minus c in the remainder theorem. So our c, our number that we evaluate p of x at, is going to be positive 1. And the trick with that is if you see a minus 1 here, put a positive 1 everywhere there's an x in here and figure out that value. That'll give you the remainder. If this were a plus 1, you'd put a negative 1 in everywhere. So we're going to evaluate p of 1. So it's going to be 1 squared plus 3 times 1 plus 5. 1 squared is going to be positive 1 because it's 1 times 1. 3 times 1 is 3 and plus 5. And if we add up all those numbers, we get our remainder of 9. Okay, problem 2. It says find the remainder when p of x equals x squared minus 5x plus 6 is divided by x minus 2. So again, the value we're going to put in for x here is going to be a positive 2 because we have x minus 2 here. So again, whatever sign we have here, switch it. So our remainder is going to be p evaluated at 2. So it's 2 squared minus 5 times 2 plus 6. 2 squared is going to be 2 times 2, that's 4. 5 times 2 is 10, plus 6. 4 minus 10 is negative 6, or negative 6 plus 6. And that's going to be 0 for our remainder. That means that x minus 2 is a factor of x squared minus 5x plus 6. So that's a little fun fact. All right, problem 3 reads, if p of x equals 2x cubed minus 4x plus 1 is divided by x minus 1, what is the remainder? So again, we're going to evaluate p at the value 1. So we're going to say p of 1 equals 2 times 1 cubed minus 4 times 1 plus 1. 1 cubed is just 1 times 1 times 1, so that's 1. So we have 2 times 1. 4 times 1 is 4, minus 4 plus 1. 2 times 1 is 2, minus 4 plus 1. So our remainder is going to be negative 1 when we add those together. Okay, number 4. What is the remainder when p of x equals x squared plus 10 is divided by x plus 3? So now to find the remainder, we're going to evaluate the polynomial at x equal to negative 3. So we're going to say p of negative 3. That's going to be negative 3 squared plus 10. Negative 3 squared is negative 3 times negative 3, which is positive 9. So we have 9 plus 10. So our remainder is going to be 19. Problem 5 says a student finds that p of 4 equals 12 for a certain polynomial. What is the remainder when p of x is divided by x minus 4? So this would be, the remainder would be p evaluated at positive 4. So p of 4, we're already given, equals 12. So the remainder is 12. Okay, next one, it says find the remainder for x cubed minus x squared plus x minus 1 divided by x minus 0. So in this case, our c is going to be 0. So everywhere there's an x here, we're going to put a 0. So the remainder is going to be 0 cubed minus 0 squared plus 0 minus 1. Well, 0 cubed is just 0 times 0 times 0, which is 0. 0 squared is 0 times 0, which is 0, plus 0 minus 1. Well, 0 minus 0 plus 0 is all 0. So our remainder is just negative 1. Number 7. If p of x equals x to the 100th power plus 1 is divided by x minus 1, what is the remainder? So again, to find the remainder, we're going to evaluate p at the value 1. So it's going to be 1 to the 100th power plus 1. So 1 to the 100th power is just 100 ones all multiplied together, and that's just going to give us plain old 1. So it becomes 1 plus 1. So p of 1 equals 2, so our remainder is 2. Okay, number 8. What is the remainder when p of x equals x squared minus 4 is divided by x plus 2? So now notice it's a plus 2 here, so we're going to evaluate p at negative 2 to find the remainder. So it's going to be negative 2 squared minus 4. Negative 2 squared is positive 4, because it's negative 2 times negative 2. A negative times a negative is a positive. So it's 4 minus 4. So our remainder is just 0 in this case, and x plus 2 is a factor of x squared minus 4. You know that if you know a little bit about difference of squares. Anyways, that's it for the problems for today. Hopefully you liked it. Okay, this is the Algebra 2 honors problems for February 18th, 2026. So problem 1, given the function f of x equals x minus 4 times x plus 2, so the quantity x minus 4 times the quantity x plus 2 times the quantity x minus 1, what are the x-intercepts of the graph? Okay, so what we're going to do is we're going to set each of the factors equal to 0 and solve for x. So first, we'll start with x minus 4 equals 0. We'll add 4 to both sides. So negative 4 plus 4 is 0, so we get x equals 0 plus 4, so x equals 4 is one of them. Then we're going to set the next factor, x plus 2, equal to 0. To solve for x here, we'll subtract 2 from both sides, and we'll get x equals negative 2. And then the last factor is x minus 1, so we'll set x minus 1 equal to 0. To solve for x here, we'll add 1 to both sides. So we'll get x equals 1. So the zeros are x equals 4, x equals negative 2, and x equals 1. Okay, problem 2. For the function f of x equals negative 2 times the quantity x minus 3 squared times x plus 5, how does the graph behave at the 0, x equals 3? So they're talking about here, and notice we're raised to the second power. So we have an even multiplicity. So what happens? Well, in this case, the graph is going to bounce off of the x-axis at x equals 3. So it bounces off the x-axis at x equals 3. Okay. Problem 3. Which of the following describes the end behavior of the graph of f of x equals x plus 1 times x minus 2 times x plus 4? You'll notice here we have x times x times x. There's like a positive 1 here, so we're going to have a positive lead coefficient, and we're going to have x to the third power as our highest, well, 3 is going to be the highest exponent, so it's going to be third degree polynomial with a positive coefficient. So that means that the graph is going to look something like this. Goes down to the left, up to the right. So as x approaches positive infinity, f of x approaches positive infinity, and as x approaches negative infinity, f of x approaches negative infinity. So the actual correct answer here is going to be C. Okay, identify the zeros of the polynomial x squared times the quantity x minus 5 times the quantity x plus 5. So we're going to set each of these factors equal to 0 and solve. So let's start with x squared equals 0. To solve for x, we're going to take the square root of both sides. And we get x equals the square root of 0. So x equals 0 is one of the zeros. We can also set x minus 5 equal to 0. And we're going to add 5 to both sides. And we're going to get x equals 5 as our other 0. And then we also want to do x plus 5 equals 0. So x plus 5 equals 0. In this case, we'll subtract 5 from both sides. And we'll get x equals negative 5 as our other 0. So the zeros are x equals 0, x equals 5, x equals negative 5. Number 5, the polynomial has zeros at x equals negative 2, 0, and 3. Which of the following could represent this polynomial? So one of the factors where x equals 0 is going to be either x, something like x squared, x cubed, something like that, where we can just set that equal to 0. So we need to have an x or something like that in there. I noticed that A has an x and B has an x. If I look at P of x in D, I see I have an x squared, but it's not in the same format. And if we were to substitute in 0 for x, we'd get, when we put in 0, we'd get P of x equals negative 3. So that's not a 0 there. So we can eliminate C and D. Okay, also, if I look at this, when I have x equals negative 2 as a 0, to get that I would have to have something like x plus 2, the factor x plus 2 equal to 0, because if we subtract 2, we'd get x equals negative 2. Now, A has x minus 2, B has x plus 2, so we're thinking B, right? We also have positive 3 as one of the zeros. In that case, I would have to have x minus 3 equal to 0. So I'd have to have the factor x minus 3 because I would add 3 to both sides, and I would get x equals 3 as my other 0. So B works, and A does not. Okay, number 6. What is the y-intercept of the function f of x equals the quantity x minus 1 times the quantity x plus 2 times the quantity x minus 4? To figure this out, we're going to plug in 0 everywhere there's an x. So we'll figure out what f of 0 is. And that's going to give us the y-coordinate, where it crosses the y-axis. So 0 minus 1 times 0 plus 2 times 0 minus 4. So we get 0 minus 1 is negative 1 times positive 2 times negative 4. Negative 1 times 2 is negative 2 times negative 4. So that's positive 8. So f of 0 is going to be 8. Now we're going to write the point where it crosses. So sometimes you might say y-intercept is y equals 8. Sometimes people write it like that. But other times they write it as a point. X-coordinate's 0, y-coordinate's 8. All right, number 7. If a polynomial has a degree of 4 and a negative leading coefficient, which of the following is true about the graph? So we know that if we have a polynomial with an even degree and a negative leading coefficient, we're going to have end behavior where it goes down on both sides. So both ends of the graph point down, B would work. It's obviously not going to be A. They're not going to point up. Let me cross that out orange. doesn't have to cross 4 times. We could have f of x equals x to the 4th power, and that would just touch the graph at 0, 0 at the origin. So it doesn't have to cross the x-axis 4 times. And both, again, it's a even degree polynomial, so both ends are going to point in the same direction. So it couldn't be b either. Okay, last one. Identify the suitable factorization of f of x equals x cubed minus 4x to find the zeros. So we want to factor this out, see what we can break it down to. So I noticed that both terms, here and here, they both contain an x. So first off, I'd start off by factoring an x. So I have x times x squared minus 4. Now x squared minus 4 is a difference of squares, so that can further be factored. So we can still have the x on the outside. And then x squared minus 4 can be factored into x minus 2 times x plus 2. Now that we got it at this point, we could set each of these equal to 0 and find the zeros that way. And that's it for this problem set. Okay, these are the Algebra 2 honors problems for February 19th, 2026. Number 1, describe the end behavior of f of x equals 3x to the 4th minus 2x squared plus 5. Okay, so when we're doing end behavior, we want to look at the term with the largest exponent. So 3x to the 4th. We don't care about any of the other terms. And we want to look at a couple things. One, the lead coefficient, the number in front of the variable that's raised to that exponent. In this case, the lead coefficient is positive. Okay? We also want to look at the exponent. So we have a 4 here. That means we have an even degree polynomial. Okay? When we have that, we have a positive lead coefficient and an even degree polynomial. We're going to have it open up on both sides. So the way we would describe that for end behavior, we'd say, as x approaches positive infinity, f of x also goes up. So f of x approaches positive infinity, and as x approaches negative infinity, it's really large negative numbers, well, f of x actually goes up. So it approaches large positive numbers, okay? So f of x approaches positive infinity. That infinity symbol is looking a little sad. Let me make that a little bit better. There we go. So in this particular case, if we're looking at it, it's going to be B is the correct solution if you're following along with the worksheet. So B is the correct solution for this one. Problem 2. For g of x equals negative 2x cubed plus 7x minus 1, what happens as x approaches negative infinity. Okay? Question mark on there. All right, so what happens? Well, we're looking at end behavior. Again, we're going to look at the lead term. So the term with the highest exponent, we have a negative lead coefficient. And we have an odd degree polynomial. Okay, so when we think about this, when we raise, we're putting in x values that are very large negative numbers. When we put in a very large negative number and we cube it, we get a very large negative number here, and we multiply that times another negative number, so we increase negative times negative as a positive. So we actually, the g of x, the function, actually is going to approach positive infinity. And the way we can write that, so we can say g of x approaches positive infinity. That one. All right. So next one, we got which function has the end behavior let's see, as f of x, well, f of x approaches negative infinity as x approaches positive at negative infinity. So what does that mean? Well, the function values get very large in the negative as x gets either very large positively or very large negatively. So we have something like this. So we want a negative leading coefficient and we want an even degree polynomial. And our choices are f of x equals 5x to the 6th plus x cubed. That doesn't work because we have a positive lead coefficient. F of x equals x squared minus 100. That one doesn't work because also there's a 1 in front of the x squared. It's a positive 1, so we have a positive leading coefficient. We have just an expression, negative 5x to the 5th plus x cubed. That doesn't work. That's just an expression, but even if it was a function, it's an odd degree polynomial. And then D is f of x equals negative 5x to the 6th power plus x cubed. So we take our lead term here, negative leading coefficient, and even degree polynomial, and that one fits. So the correct solution is f of x equals negative 5x to the 6th plus x cubed. Problem 4. What is the end behavior of p of x equals x minus 2 times x plus 3 times 1 minus x. Okay, so notice this is they kind of shifted it here. In this last binomial, 1 minus x versus negative x plus 1. So I could rewrite it as x minus 2 times x plus 3 times negative x plus 1. Okay, and that's going to help me because my lead term is going to be, let's do a different color, it's going to be x times negative x. So my lead term is going to be negative x cubed. Right? So, and that's a negative 1. So we have a negative lead coefficient. And we have an odd degree polynomial. So your shape is going to be something like this. So it's going to go up to the left, down to the right. So the way we can say that, and the way we've got a description here, let's see, so up on the left, down on the right, which is D. We could describe it that way. Okay, that's number 4. All right, 5. If f of x equals ax to the nth power plus whatever, and as f of x approaches, and f of x, here we write this, and f of x approaches positive infinity as x approaches positive infinity, but f of x approaches negative infinity as x approaches negative infinity, which must be true. Okay, so let's see what we're talking about here. So as x goes right, f of x goes up, and as f of x goes down, as x goes left. So we have something like this. That means we have a positive lead coefficient. So a is positive, and an odd degree polynomial. N is odd. And so D, n is odd, and a is greater than 0 works. Okay, problem 6. Describe the end behavior. Let me write that. Describe the end behavior of f of x equals negative x squared times x squared minus 4. So negative x squared times x squared, that's going to be negative x to the 4th for our lead term. So our leading coefficient is negative. Negative lead coefficient. And that's from the negative 1 here. And then we also have an even degree polynomial. So the shape we're going to draw the shape quick. It's going to go down on both sides. Right? And so, the description here would be as x approaches positive and negative infinity, f of x approaches negative infinity, because it goes down on both sides. So in that case, it was A as the solution. All right, number 7. True or false? A polynomial of degree 5 can have both ends pointing toward positive infinity. Both ends pointing toward positive infinity. Well, in this case, the answer is false, because a polynomial of degree 5 is odd. That means one end is going to go up, one end is going to go down. So they both can't be pointing in the same direction. So that one is false. All right, problem 8. What is the end behavior of h of x equals 10 minus x to the 5th plus x squared? Okay, so we got to look for the term with the highest exponent. That's going to be this negative x to the 5th. So this is like a negative 1 x to the 5th. So in that case, we have a negative lead coefficient. And we have an odd degree polynomial. So the shape, let's pick a different color, let's do blue. Shape is going to be something like that. It's going to go down to the right, up to the left. So I would say as x approaches positive infinity, h of x, so as we go this way, h of x goes down. So h of x approaches negative infinity, and as x approaches negative infinity, so it goes this way, it's going to go up. So h of x will approach positive infinity. Okay, so that's how I would describe it. In this case, that's A. All right, these are the Algebra 2 problems for the day on February 19th, 2026 on the remainder theorem. So problem 1, if p of x equals x squared plus 2x plus 1, and that is divided by x minus 1, what is the remainder? Okay, so to do this problem, we're going to look at the divisor, specifically this number is -1 here, and we want to figure out the x value that makes the divisor equal to 0. So it would actually be +1, because 1 minus 1 would be 0. So we're going to take +1, and we're going to evaluate this polynomial p at 1, and that's going to give us the remainder. So the remainder is going to be 1 squared plus 2 times 1 plus 1. 1 squared is just 1 times 1, which is 1. 2 times 1 is 2, and then plus 1. 1 plus 2 plus 1 is 4. So our remainder in this case is 4. Okay, problem 2. What is the remainder when p of x equals x squared minus 4 is divided by x minus 2. All right, to solve this problem, we're going to look at our divisor again, and we're going to figure out what x value makes the divisor equal to 0. So if I put in 2, it would make 2 minus 2, 0. Another way to think of this is we could look at this number here and just change the sign. So instead of -2, we're going to use +2. And we are going to evaluate the polynomial at that number, +2. So we have p of 2 equals 2 squared minus 4. This is going to give me the remainder. So 2 squared is 2 times 2, which is 4. So 4 minus 4. So 4 minus 4 is 0. P of 2 equals 0. So by the remainder theorem, our solution is, our remainder is 0. All right, problem 3. We are going to find the remainder for x squared minus 7x plus 10 divided by x plus 3. So, easy way to do this is we're going to evaluate this x squared minus 7x plus 10 when we're going to take this number, +3, make it -3, and put the -3 everywhere there's an x here. So our remainder is going to be -3 squared minus 7 times -3 plus 10. -3 squared is -3 times -3, that's +9. So we have 9, then we have minus 7 times -3. It's going to be plus 21 plus 10. So 9 plus 21 plus 10 is 40. So our remainder is 40. Problem 4. If p of 3 equals 10, what is the remainder when p of x is divided by x minus 3? Okay. In this case, remember with our remainder theorem, we're going to take this number here and just change the sign and evaluate the polynomial at that number. So we'd evaluate the polynomial p of x at 3, and that value is going to be our remainder. So long story short, our remainder is just 10. Okay, what is the remainder? Number 5, what is the remainder when p of x equals 2x squared minus x is divided by x minus 0. Okay, so normally we take whatever this value is and change the sign and put it in for the x values and evaluate the polynomial at that number. You really can't have a minus or plus 0. We're just going to put it in 0. So the remainder is going to be p evaluated at 0. So it's going to be 2 times 0 squared minus 0. 0 squared is just 0, so it's 2 times 0 minus 0. 2 times 0 is just 0, so it's 0 minus 0, which is just 0. Our remainder is 0. Fun fact, x minus 0 is going to be a factor of p of x. Okay, number 6. Find the remainder for x cubed plus 1 divided by x plus 1. Okay, so we're going to take this number here and change the sign and put it into here. Okay, so we're going to evaluate this at negative 1 cubed plus 1. Now, a negative number raised to an odd power is negative. The reason being negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1 plus 1 is going to be 0. So our remainder is going to be 0. X plus 1 is also a factor of x cubed plus 1. Okay, problem 7. A student evaluates p of negative 2. Student evaluates p of negative 2 to find the remainder of p of x equals, or sorry, p of x divided by x plus 2. If p of negative 2, if that equals 5, the remainder is okay, so normally when we're using a remainder theorem, we take this number, change the sign, and evaluate the polynomial at that number. They already said that we've evaluated p of negative 2, and that equals 5, so it's very easy. The remainder here is the value of p of negative 2. So the remainder is 5. Number 8. What is the remainder of x squared plus x plus 10 divided by x minus 2? Okay, so we are going to take this and change the sign to make it positive 2, and we're going to put that in for x in x squared plus x plus 10. So I'm going to say 2 squared plus 2 plus 10, that's going to be our remainder. 2 squared is 2 times 2, that's 4. So 4 plus 2 plus 10 4 plus 2 is 6, and 6 plus 10 is 16, so our remainder here is 16. And that's it for the college prep problems. Okay, in problem 1, we've got two equations here. We've got kx minus 3y equals 4, and 4x minus 6y equals 7. And the problem reads, in the system of equations above, k is a constant. If the system has no solution, what is the value of k? Well, if I were to double the top equation, so if I were going to multiply the top equation by 2, so I would get 2kx minus 6y equals 8. And if I had my bottom equation, 4x minus 6y equals 7, if the value in front of x was the same, then the values of y are the same, but these two constants are different, we're going to have parallel lines, and when we have parallel lines, we have no solutions. So really what I've got to do is I've got to set 2k equal to 4 and solve for k. So set 2k equal to 4, divide both sides by 2. The 2's cancel out here, and we get k equals 4 divided by 2, so k equals 2 is my solution to the first one. In this second problem here, we have two equations, y equals x squared and y equals 2x plus 3. It says, if xy is the solution to the system of equations above, and x is greater than 0, what is the value of x? So notice we've got y equals x squared and y equals 2x plus 3. So I'm going to set x squared equal to 2x plus 3. I then want to move the 2x and the 3 over. So if I subtract 2x and 3 from both sides, 2x minus 2x equals 0, 3 minus 3 equals 0, so the right-hand side becomes 0. The left-hand side is x squared minus 2x minus 3. That equals 0. And what I can do is I can factor this now, so this has a coefficient in front of x squared of 1. So if I look for the two factors of negative 3, 1 and negative 3, which add to negative 2, I then can write my factored form as x plus 1 times x minus 3. That equals 0. And then I can set, well, I want the positive value of x. So if I set x plus 1 equal to 0, to solve for x, I would have to subtract 1 from both sides. And that would give me the negative value of x. So I don't want to do that. Instead, what I want to do is I want to set x minus 3 equal to 0. Then to solve for x, I'm going to add 3 to both sides. Negative 3 plus 3 is 0, so I get x equals 0 plus 3, so x equals 3 is my positive solution for x. That's the one they're looking for. Okay, problem 3 reads, a snack bar sells popcorn bags for $3 and pretzel bags for $2. If they sell a total of 100 bags and make $240, write a system of equations to represent this situation. Let's let the popcorn be x and the pretzels, let's let them be y. So I could say that the total number of pretzel or popcorn bags plus the total number of pretzel bags, well, that's going to equal the total number of bags sold, so that's going to equal 100. And then each popcorn bag sold for $3, so if I do 3 times however many popcorn bags I sell, plus each pretzel bag costs $2, so plus 2 times however many pretzel bags that I sell, well, that's going to equal the total cost, which is $240. And here is my system of equations. Notice with this top equation, if I multiply the top by 2, 2 times 3x is 6x, 2 times y is 2y, and 2 times 7 is 14. If I want to have infinite solutions, I want to have the same line. So I have ax plus 2y equals 14 on my bottom. So if I make a the same as the number in front of x in the blue equation, then I'll have the same line and have infinite solutions. So I can say a equals 6. Okay, these are the do now problems for my Algebra 2 college prep class on February 26, 2026. So first one, a gamer is downloading a 120 gigabyte update. Their internet speed is a steady 15 gigabytes every 4 minutes. How long in minutes will it take to finish the download? Enter only the number. All right, so we know that we can do 15 gigabytes in 4 minutes, okay? But we want to do 120 gigabytes, and we don't know the time that that's going to take, so we're going to write that as x, or unknown. And what we can do is what a lot of students call the butterfly method. I call it cross multiplication. But what we can do is now we can solve this proportion here for x. If we do 15 times x, so we get 15x equals 120 times 4. 120 times 4 is 480. And then to solve for x, we'll divide both sides by 15. 15 divided by 15 is just 1, so we have 1x equals 480 divided by 15, so that's going to be 32. So 32 minutes is going to be our solution for this problem. Let's do a different color for this one. Let's do a purple. An electric car charging station delivers 12 kilowatt hours of energy every 10 minutes. If the car charges at this constant rate for 1.5 hours, how many kilowatt hours will it receive? Okay, so for every 10 minutes, we get 12 kilowatt hours. Okay, but we want to know for 1.5 hours. So one thing I want to know is how many minutes are in 1.5 hours. Well, there's 60 minutes in an hour, so half of that is 30, so 60 plus 30 will be 90 minutes. So for 90 minutes, we want to know the time. That's our unknown. We'll call that x. And again, we'll do 10 times x, so we get 10x equals 90 times 12, which is going to be 1,080. Okay, to solve for x, we'll divide by 10. 10 divided by 10 is 1, so we get x equals then 10,080 divided by 10. Really, it's just 108 divided by 1 if we cross off the 0. So it's 108, and that's kilowatt hours. So 108 is our solution here. Okay, for our next one, we have a gourmet coffee shop roast 14 pounds of beans every 8 minutes. At this rate, how many pounds of coffee can they roast in a typical 6-hour workday? Okay, so set up our proportion. So we have 14 pounds for every 8 minutes. Now a 6-hour workday, that's 6 times 60, so that's 360 minutes. We want to know how many pounds they can roast. So we do x times 8, which is 8x, equals 14 times 360. So 14 times 360, well, we got, let's see, 4 times 6 is 24, 4 times 3 is 12, plus 2 is 1440, and plus 360, so we get 0. We're going to get 5,040. And then what we want to do is we want to divide both sides by 8. 8 divided by 8 is 1, so we get x equals, and then 5,040 divided by 8, well, let's do that. So 8 goes into 50, it's going to be 6 times. So 6 times 8 is 48. 50 minus 48 is 20, and then we bring down the, or is 2, bring down the 4. So 8 times 3 is 24. And we have another 0 we bring down. So 630. So it's going to be 630 pounds of beans. So that would be our answer for that one. All right, an algorithm shows a user 9 targeted advertisements for every 12 minutes of scrolling. So for every 12 minutes, you get 9 advertisements. So if the user scrolls for 40 minutes, how many advertisements will you get? So I have 12 over 40 equals 9 over x. So again, do my cross multiplication. So 12 times x is 12x. And then that's going to be 40 times 9. So that's going to be 360. Divide both sides by 12. And you're going to get x equals 30 advertisements. All right. These are the honors do now problems from February 26, 2026. A small circular pizza has a diameter of 8 inches and a large circular pizza has a diameter of 16 inches. How many times more dough area is used for the large pizza compared to the small one? Well, let's do the area of the small. That's going to be equal to pi times the radius squared. Now the radius is going to be half of 8 inches, so it's going to be pi times 4 inches squared, so 16 pi square inches. Okay. The area of the large is going to be pi, again, times that radius squared, so pi times half the diameter, so half of 16, so pi times 8 inches squared, which is going to be 64 pi square inches. Now if we divide, we don't have to worry about the pi inches, pi square inches. If we just divide 64 by 16, we see that it's going to be 4 times the area, because again, we're squaring that radius. All right, let's look at this next problem. We have garden A is a square with a side length of s feet. Garden B is a square with a side length of 5s feet. How many times larger is the area of garden B than garden A? So let's say the area of A is going to be, well, the side squared. So it's just going to be s squared. The area of B is going to be, again, the side squared, but this time the side is 5s, so it's going to be 5s times 5s, which is just 25s squared. We divide 25s squared by 1s squared, we see that the area is 25 times larger. Okay, let's look at this next one. On a blueprint, a circular fountain has a radius of r centimeters. In the actual park, the fountain is built with a radius of 12 centimeters. What is the ratio of the area of the actual fountain to the area of the blueprint drawing? So the area of the blueprint is going to be pi times r centimeters squared. So it's going to be pi r squared centimeters squared. The area of the actual is going to be pi times 12r centimeters squared. So it's going to be 144 pi r centimeters squared. So instead of 1 pi r squared centimeters squared, it's 144. So our ratio is going to be 144 to 1. Okay, last one. A radio tower broadcasts a circular signal with a radius of 10 miles. If the power is boosted to increase the radius to 60 miles, by what factor of total coverage area, or by what factor did the total coverage area increase? So again, the initial area, we'll call that area I for initial, is going to be pi times the radius squared, so pi times 10 miles squared, so 100 pi miles squared. The area of the extended coverage, I'm going to call it A sub E, is again pi times whatever the radius squared is, but this time the radius is 60 miles, so it's pi times 60 miles squared, which is going to be 3,600 pi miles squared. So if I divide 3,600 by 100, I'm going to get a factor of 36. So 36 times. Okay, here are the Algebra 2 college prep problems on the remainder theorem for February 26, 2026. In section 1, we are finding the remainder using the remainder theorem. In problem 1, we've got f of x equals x squared plus 5x plus 6, and that's divided by x minus 1. So our remainder is going to be, we're going to take this minus 1, we're going to make it positive 1. We're going to say f of 1 is our remainder. That's going to be 1 squared plus 5 times 1 plus 6. 1 squared is 1 times 1, so that's just 1. 5 times 1 is 5. And then plus 6, that's going to equal 12. So our remainder to problem 1 is going to be 12. In problem 2, we've got f of x equals x squared minus 3x plus 10, and that's divided by x minus 2. So instead of plugging in negative 2 for x, we're going to plug in a positive 2. So our remainder is going to be function f evaluated at 2. So it's going to be 2 squared minus 3 times 2 plus 10. 2 squared is 2 times 2, so that's 4. Minus 3 times 10, or 3 times 2 is 6, plus 10. So 4 minus 6, which is negative 2, plus 10, gives you a positive 8 for the remainder. In our third one, we've got f of x equals 2x squared plus 4x minus 5, and it's divided by x minus 3. Our remainder is going to be f of 3. So we're going to plug in 3 for x. So it's going to be 2 times 3 squared plus 4 times 3 minus 5. 3 squared is 3 times 3, so it's going to be 2 times 9 plus 4 times 3 is 12 minus 5. 2 times 9 is 18, so I have 18 plus 12 minus 5. 18 plus 12 is 30, minus 5 is 25 for a remainder for that one. For the last one in the first section, we have f of x equals x cubed plus 2x squared minus x plus 4 divided by x minus 1. So our remainder, instead of a minus 1, we're going to put a positive 1. So our remainder is going to equal function f evaluated at 1, which is 1 cubed plus 2 times 1 squared. Let me erase this stuff. It's 2 times 1 squared plus 4. 1 cubed is 3 1s multiplied together, which is still just 1. 1 squared is 2 1s multiplied together, so that's 1 times 1, which is 1. Plus 4. 2 times 1 is 2. So we have 1 plus 2 plus 4. That's going to be 7 for our remainder. Whoops, I messed up. My bad. So this part up here, what did I forget? I forgot the minus x. So minus 1 plus 4. So 1 cubed, again, is 1 plus 2 times 1 minus 1 plus 4. 2 times 1 is 2, so 1 plus 2 minus 1 plus 4 is 6 for that one. Okay, in section 2, same thing, but we're finding the remainder, but this time we have binomials with a positive here. So for number 5, we have f of x equals x squared plus 8x plus 12, and that's divided by x plus 1. So our remainder is going to equal f evaluated at -1, because we changed the sign. So basically whatever number we're going to put in here is going to make this binomial equal to 0. So -1 plus 1 is 0. That's why we're putting in a -1. So we have -1, so we have -1 squared plus 8 times -1 plus 12. -1 squared is -1 times -1, which is +1, plus 8 times -1 is -8, plus 12. 1 plus -8 is -7, plus 12 is +5. In problem 6, we have f of x is 3x squared minus 5x plus 2 divided by x plus 2. So we're going to find the remainder by finding f of -2. So it's going to be 3 times -2 squared minus 5 times -2 plus 2. -2 squared is -2 times -2, which is +4, so we have 3 times 4. -5 times -2 is +10, so plus 10 plus 2. 3 times 4 is 12, plus 10 plus 2 is going to be 24 for the remainder for that one. Problem 7, we've got f of x equals x cubed minus x squared plus x divided by x plus 3. So our remainder is going to be function f evaluated at -3. So f of -3, which is -3 cubed minus -3 squared plus 4. -3 cubed is 3 -3's multiplied together. So -3 times -3 is +9. Multiply by another -3, you get -27. -3 squared is -3 times -3, which is +9. So -27 minus 9 plus 4. -27 minus 9 is -36 plus 4. So our remainder in this case is -32. In our last one in this section, we've got f of x equals 2x cubed plus 10 divided by x plus 2. So our remainder is going to equal the function evaluated at -2, which is going to be 2 times -2 cubed plus 10. So -2 cubed is -8, so 2 times -8 plus 10. So it's going to be -16 plus 10. So the remainder is -6 for the last one in that section. In section 3, is it a factor? So if the remainder is 0, the binomial is a factor. Answer yes or no to the following, showing your work. So is x minus 1 a factor of f of x equals x squared minus 4x plus 3? So again, if f of +1 equals 0, then the answer is yes. So f of 1 is going to be 1 squared minus 4 times 1 plus 3. 1 squared is 1, 4 times 1 is 1, so 1 minus 4, which is -3, plus 3 equals, well, that's 0. So the answer to the first one is yes, that's a factor. Next one, is x plus 2 a factor of f of x equals x squared plus 5x plus 6? So if f of -2 equals 0, then the answer is yes. So we have -2 squared plus 5 times -2 plus 6. -2 squared is +4. 5 times -2 is -10, so 4 plus -10 plus 6. 4 plus -10 is -6, plus 6 is 0. So for this next one, or the second one, the answer is also yes. It's also a factor. Problem 11. is x minus 3 a factor of f of x equals x cubed minus 27? So we're going to figure out what f of 3 is. If that's 0, the answer is yes. If not, the answer is no. So we have negative 3 cubed minus 27. Negative 3 cubed is a negative 27. So negative 27 minus 27, that's negative 54. That's not 0, so the answer is no. Last one, is x plus 1 a factor of f of x equals 4x to the 10th power minus 4? So we're going to evaluate f of negative 1, which is going to be 4 times negative 1 to the 10th power minus 4. A negative raised to an even power is positive, so that's going to be positive 1. So it's going to be 4 times 1 minus 4, or 4 minus 4, which is 0. So the last one, the answer is yes. All right, these are the Algebra 2 honors problems for February 26, 2026, dealing with end behavior of polynomials. So in this first section, it says determine the end behavior of the following functions using the format as x approaches infinity, f of x approaches either positive or negative infinity, and as x approaches negative infinity, f of x either approaches positive or negative infinity. So this first one, we have f of x equals negative 4x to the fourth plus 3x squared minus 1. We want to look at the term that has the largest exponent. That term is negative 4x to the fourth. This is an even degree polynomial with a negative lead coefficient, meaning it's even degree polynomial, so both end behaviors go in the same direction, and it's negative, so they both go down. Negative, like a frown. Okay, so the way we can write that is we say as x gets really large, so as x approaches positive infinity, well, f of x, it's really large negative. So f of x approaches negative infinity, and then let's go the other direction on x. So as x gets really large negative, so as x approaches negative infinity, and what does f of x do? Well, f of x approaches a very large negative number, so f of x approaches negative infinity. So this here would be my answer for that one. In the next problem, we've got g of x equals 1/2 x to the fifth minus 10x cubed plus x. So again, we want to look at the exponent, or the term with the largest exponent. So in this case, 1/2 x to the fifth power, which is odd. So the end behaviors go in different directions, and it's a positive lead coefficient. So it goes up to the right. So something like this. Now in between, there could be a bunch of stuff going on, but if you zoom out large enough, when you get really large numbers, it's going up, really large x values, and you get really small x values, it's going down. So to write that with the end behavior terminology, we say as x approaches positive infinity, well, f of x goes up, so f of x also approaches positive infinity, and as x gets really small, as x approaches negative infinity, well, f of x goes down, so f of x approaches negative infinity. Okay. And here's our answer for this one. Okay, problem 3. We've got h of x equals 15 minus 2x squared minus x cubed. Now, the lead term that we picked in the previous ones was the first term written. But in this case, we're looking for the one with the highest exponent. So the one with the highest exponent is negative x cubed. And that's like a negative 1 x cubed. So it's an odd degree polynomial with a negative lead coefficient. So that means it goes down to the right. And again, anything can be happening in between. So we're going to say, as x gets really large, as x approaches positive infinity, f of x gets really large negative, so f of x approaches negative infinity, and going the other way, let's do this color, as x gets really large negative, so as x approaches negative infinity, well, in this case, f of x goes up, so f of x approaches positive infinity. Yeah, that infinity sign is a little bit not great. Fix that. And it's a little bit better. All right. And this is my answer here. Okay, so number 4 is a bit different. We've got p of x equals negative x times x minus 3 squared times x plus 1. So really, my lead coefficient is going to be negative x times, well, this is x minus 3 squared, times an x squared times another x. So that's going to be a negative x to the 4th power. Okay, it's going to be my lead coefficient. So it's even degree polynomial, and we have a negative 1 here, so a negative lead coefficient. So they're both going to open the same direction. Again, anything can happen in between, but the end behaviors are both going to be going down. So as x approaches positive infinity, the f of x values drop, so f of x approaches negative infinity, and going the other way, as the x values get really large negative, so, and as x approaches negative infinity, well, the f of x values go down, so f of x approaches negative infinity. That's my answer for that one. All right, let's move to section 2. So section 2 is labeled factor, form, and roots. Predict the end behavior and identify the maximum possible number of turning points. So the maximum number of turning points for a polynomial of degree n is n minus 1. So let's look at this first one. If we take x times x times x, we've got f of x equals x plus 2, quantity x plus 2 times quantity x minus 1 times quantity x minus 5. So to figure out the lead coefficient, we do x times x times x, so it's going to be x cubed, which is a 3rd degree polynomial. So the maximum number of turning points is going to equal 3 minus 2, which, sorry, 3 minus 1. 3 minus 1, which is going to be 2. Okay, so a maximum of 2 turning points. All right, so now we also want to figure out the end behavior. So this is an odd degree polynomial, 3 is odd, and it has a positive 1 for the lead coefficient, so positive lead coefficient. So it's going to open up to the right. So what we're going to say is, as x approaches positive infinity, f of x also is going up. It's approaching positive infinity, and going the other way, as x is approaching negative infinity, f of x is going to go down. So f of x approaches negative infinity. All right, this next one, we are mixing it up. We've got a j of x. So we've got a negative 2x squared times the quantity x plus 4 times the quantity x minus 7. So let's do negative 2x squared times x times x. When we multiply that out, we get negative 2x to the fourth. So we have a fourth degree polynomial. It's even. And we have a negative coefficient. So because it's fourth degree polynomial, so the max, abbreviate this, number of turning points well, that's going to be 4 minus 1, so it's going to be 3 is the max number of turning points. And then, because it's even degree, it's going to open to the same direction, and it's going to, because it has a negatively coefficient, they're both going to be going down. So as x is getting, draw that up here, as x is getting large negative, so as x is approaching positive infinity, f of x is going down, so f of x is approaching negative infinity, and let's do different color. As x is approaching negative infinity, well, f of x is going down. So f of x is approaching negative infinity. Number 7. We've got k of x equals negative 1 times the quantity x plus 1 cubed. So the quantity x plus 1 cubed is going to have an x cubed if we expand that out. And then you have negative 1 times that. So you're going to have negative 1x cubed as your lead coefficient. So again, third degree polynomial, odd, negative lead coefficient. So the max number of turns are turning points. That's going to be 3 minus 1, which is 2. And because it's odd and there's a negative lead coefficient, it's going to go down to the right, up to the left. So as x approaches positive infinity, f of x goes down. So f of x approaches negative infinity, and as x goes very large negative, so x approaches negative infinity, well then f of x goes up. So f of x approaches positive infinity. All right, last one. We've got m of x equals x squared times the quantity x minus 2 squared times the quantity x plus 2 squared. So essentially what we have here is we have an x squared. I'll do that in a different color. We have an x, whoops, x squared X minus 2 squared is going to give another x squared, so times another x squared times x plus 2 squared is going to give me another x squared. So our lead coefficient is going to be a positive 1x to the 6th. So 6-degree polynomial, so the max number of turning points is going to be 6 minus 1, so that's going to equal 5. It's even and has a positive lead coefficient, so even degree, positive lead coefficient. That means both are going to open up for my end behavior. Now there could be a bunch of stuff happening in between, but both open up. So as x approaches positive infinity, well, f of x goes up. So f of x approaches positive infinity, and as x gets large negative, so as x approaches negative infinity, well, f of x also goes up here, so it's going up here, so f of x approaches positive infinity. All right, these are the honors due now problems from February 27, 2026. First one reads, a rectangular backyard deck has an area of 6 square yards. What is the area of the deck in square feet? And it notes that 1 yard equals 3 feet. Well, 1 yard equals 3 feet, but 1 square yard is going to equal 3 feet squared. So 3 feet squared is 3 times 3, that's 9 square feet. So 1 square yard equals 9 square feet. So to answer this question, since we have 6 square yards, we're going to have to do 6 times 9 square feet, and that's going to give us 54 square feet. So 54 is my solution to that one. In this next one, it says a commercial solar farm covers an area of 0.8 square kilometers. What is the area of the solar farm in square meters? It notes that 1 kilometer is 1,000 meters, but we're talking square kilometers, so 1 kilometer squared, 1 square kilometer, is going to be 1,000 meters squared, so it's going to be a million square meters. And we want 0.8 times that, so we're going to do 0.8 times 1 million, and that's going to be 800,000, and that's meters squared, so we can select that one. Okay. The next one, a specialized microchip has an area of 1.5 square meters. What is the area of a chip in square millimeters? So to figure this out, we're going to do, we've got to figure out how many square millimeters are in 1 square centimeter. So 1 centimeter squared is going to be 10 millimeters squared, which is going to be 100 square millimeters. And we have 1.5 square centimeters, so I'm going to take 1.5, and we're going to multiply it by 100 square millimeters. And that's going to give us 150 square millimeters. In our last one, an interior designer is looking at a rug that covers 12 square meters. If the designer needs to know the area in square centimeters, what is the final value? 1 meter equals 100 centimeters. So 1 square meter, or 1 meter squared, is going to equal 100 centimeters squared, which is going to equal 10,000 square centimeters. And we want 12 of those, so we want to do 12 times 10,000 square centimeters, so it's going to be 120,000 centimeters squared. For this one, I had students enter without a comma, so you just enter a 1, 2, and then 4 zeros. Okay, these are the Algebra 2 college prep problems for February 27th, 2026. First one, a group of friends spent $54 on popcorn and sodas at the theater. Popcorn costs $8 per bucket and sodas cost $5 each. If the group bought 3 buckets of popcorn, how many sodas did they buy? So they bought 3 buckets of popcorn, so they've already spent 3 times the $8 it costs per bucket. So that would be $24. If they started with $54, they're going to have to subtract that $24 they spent, so they have $30 to spend on soda. Now each soda costs $5, so we're going to take that $30 and we're going to divide it by $5, and so we're going to get 6 sodas that they can buy. Next one, Taylor pays a total of $95 per month for streaming services. Premium movie passes cost $15 each, and basic music plans cost $10 each. If Taylor subscribes to 3 premium movie passes, how many basic music plans do they have? So they're going to spend, well, it's 3 times the $15 that they spend on the premium movie pass for each one. So it's going to be $45 they spent on the premium movie passes. If I take that away from the $95 that they had to start with, 95 minus 45, that's going to be $50 left, and each basic music plan costs $10, so I'm going to take $50 and divide by $10. 50 divided by 10 is 5, so they were able to get 5 basic music plans. Okay, next one, a school gym ordered new weights for a total of $320. Large plates cost $45 each, and small plates cost $20 each. If a coach ordered 4 large plates, how many small plates were included in the order? So we have 4 times the $45 it costs for each large plate. That's going to give me $180 spent on the large plates. If I take that away from the $320, so $320 minus $180 gives me $140 to spend on small plates. Each small plate costs $20, so if I divide $140 by $20, that gives me 7. So they can buy 7 small plates. All right, next one, a repair shop charges a flat diagnostic fee plus an hourly labor rate. A customer's total bill was $165. The diagnostic fee is $45 and the labor rate is $30 per hour. How many hours of labor were billed? So let's take the $165, we'll subtract off the $45 diagnostic fee. That gives you $120 left. For the hourly rate. Each hour costs $30. So if we do 120 divided by 30, that gives us 4 hours that were billed. So I would enter just the number 4 here. All right, we are looking at, this is Algebra 2, some SAT style review questions for the college prep students. Number 1 reads, a special deck of cards contains 40 cards numbered 1 through 40. If you draw one card at random, what is the probability that the number on the card is a multiple of 8? Well, the multiples of 8 are 8, 16, 30, 24, 32, and 40. So there are 5 multiples of 8 from 1 to 40. So probability is the number of favorable outcomes. So probability of a multiple of 8 is the number of favorable outcomes. So in this case 5 over the number of total outcomes. There's 40 cards, so 40. That could be simplified to 1 over 8, which we can also write, we divide 1 by 8 as, let's just say, or 0.125. Okay. Next one, an arcade game features a digital spinner divided into 32 equal sections, numbered 1 to 32. On a single spin, what is the probability of landing on a number that is less than 7 or greater than 30? So there are 6 numbers that are less than 7, and there are 2 numbers from 1 to 32, being 31 and 32, 2 numbers that are greater than 30. So either of those 2 possibilities will be a favorable outcome. So there's 6 plus 2, 8 favorable outcomes. So we could say the probability of less than 7 or greater than 30, that's going to equal 8 over the total number of outcomes, which is 32. We could simplify that to 1 over 4, or you could write that, if you divide 1 by 4, you get 0.25. All right, so that's the first 2. Problem 3 reads, a community center charges a flat cleaning fee of $75 plus an additional $40 per hour to rent a hall for a birthday party. A family wants to rent the hall for H hours, but needs to keep the total cost to no more than $300. Write an inequality that represents this situation. So no more than $300 would be less than or equal to $300. There's the flat cleaning fee of $75. I have a cold, I'm having trouble talking today. So the flat cleaning fee is $75, and then we have to add that to the hourly fee. So 40 times H, which is however many hours that you are at the community center. So that's our inequality for number 3. Number 4 reads, a city's electric scooter share program costs $2.50 to unlock a scooter plus a usage fee of 35 cents per minute. If a rider has a maximum of $15 in their account, which inequality represents the number of minutes M, they can ride without overspending. So the max is 15. Now when it says maximum, that's also less than or equal to. You have to pay the $2.50 to unlock the scooter, and then you have a fee per minute of 35 cents per minute. So we're going to do 0.35 times however many minutes M that they rent the scooter. And that's our inequality for that one. Number 5. A busy coffee shop brews 12 cups of coffee every 5 minutes during the morning rush. At this constant rate, how many cups of coffee will the shop brew in 2 hours? Okay, so we have 12 cups of coffee for every 5 minutes. We want to know for 2 hours. So 2 hours is 60 times 2, 120 minutes. And we don't know the amount, or the amount of cups of coffee, so we're going to call that x. And what we can do now is we can cross multiply. So we can say 5x equals 12 times 120. 12 times 120 is 1440. So 5x equals 1440. And then if we divide both sides by 5, well, we're going to get x equals, let's do 1440 divided by 5. So 5 goes into 14 twice. 2 times 5 is 10. 14 minus 10 is 4. Bring down the next 4. 5 goes into 44 8 times. 8 times 5 is 40. 44 minus 40 is 4. Bring down the next 0. 5 goes into 40 exactly 8 times. 40 minus 40 is 0. So x is 288. So it's going to be 288 cups of coffee for that one. An electric car charging a level 2 station gains 18 miles of range for every 45 minutes. So let's set up a proportion. So we have 18 for 45 minutes when it's plugged in. If the car charges at this constant rate for 3 hours, so that's 3 times 60, so 180 minutes. How many miles of range will be added? That's the unknown. Okay. Now we can make this easier because 45 goes into 180 exactly 4 times. So I'm going to say 1 over 4. Then when I multiply across, I do x times 1, which is just x, equals 4 times 18, so that's 72. So we get 72 miles of range. Okay, number 7, the function h is defined by the equation h of x equals x squared minus 4x plus 7. What is the value of h of x when x equals negative 3? So we're going to say h of negative 3, well, it's going to equal negative 3 squared minus 4 times negative 3 plus 7. Negative 3 squared is positive 9. Negative 4 times negative 3 is positive 12 plus 7. That's going to be 28 for that one when we add 9 plus 12 plus 7. Okay, number 8. The function f is defined by the equation f of x equals 2/3 x plus 10. What is the value of f of 24? So where there's x, we're going to put in 24. So we're going to say f of 24 equals 2/3 times 24 plus 10. Well, 1/3 of 24 is 8, so 2/3 of 24 is 16. So f of 24 is going to be 16 plus 10, which is 26. Okay, number 9. Square A has a side length of 3k and square B has a side length of 12k, where k is a positive constant. How many times larger is the area of square B compared to the area of square A? So the area of A is going to be the side squared. So we're going to take 3k and we're going to square it, which is going to be 9k squared. The area of B is going to be the side 12k squared. So 12 times 12 is 144. So we're going to have 144k squared. Now how many times larger? Well, we have to divide 144 by 9. Dividing 144 by 9, you get 16. So it's actually 16 times larger because you're squaring the sides, even though the sides are only 4 times, or side B is only 4 times side A. Because you square the sides, the area is 16 times as large. Okay, similar problem for number 10. Circle P has a radius of 5w and circle Q has a radius of 25w, where w is a positive constant. If the area of circle Q is n times the area of circle P, what is the value of n? Okay, so the area of P, that's going to be pi times the radius of P squared. So it's going to be pi times 5w squared. 5w squared is 5w times 5w. That's 25w squared. So we can write the area as 25 pi w squared for P. The area of Q is pi times the radius of Q squared. So it's going to be pi times 25w squared. 25 times 25 is 625. So it's 625 pi w squared. Now n is the amount of times you have to multiply this by to get this. Well, we just saw that 25 times 25 is 625. So n is 25. And we're done with that set of problems. Okay, here is the SAT review questions for my Algebra 2 honors on February 27, 2026. 1 through 4 were actually included in the college prep, so we're going to go to 5 because I'm going to include the college prep ones in this video. So, first question says the measure of angle x is pi 6th radians. The measure of angle y is 2 pi 3rds radians greater than the measure of angle x. What is the measure of angle y in degrees? So we're going to take pi 6th, and we want to add 2 pi 3rds to that, but I want a denominator of 6, so I'm going to add 4 pi 6th. 1 pi plus 4 pi is 5 pi 6th. And to change that to degrees, I'm going to multiply by 180 degrees over pi. Now the pi's here will cancel when we multiply across. 6 goes into 180 30 times. So when I multiply across, now it's 5 times 30 degrees, so 150 degrees. This is essentially 1 over 1 times 1. Anything divided by 1 is just itself. So the answer here is 150 degrees for that one. Number 6. The measure of angle J is 3 pi 4ths radians. The measure of angle K is pi half radians less than the measure of angle J. What is the measure of angle K in degrees? So we have 3 pi 4ths radians. We're going to subtract, instead of pi over 2, I'm going to do 2 pi over 4, which is the same thing. We just want the same denominator. So 3 pi minus 2 pi is 1 pi over 4. To multiply, or to change that to degrees, we're going to multiply it by 180 degrees over pi. Again, when we multiply across, the pi's cancel. So we get 1 times 180, so 180 degrees over 4 times 1, so 4. 180 degrees divided by 4 is 45 degrees. So that is the measure of angle K. All right, number 7 says the perimeter of a regular hexagon is 480 inches. So a regular hexagon has 6 sides. A line drawn from the center of the hexagon to the midpoint of one of its sides, a line is drawn from the midpoint of one of the sides to the center. That's the apothem. The length of this line is k over 3, or k times the square root of 3 inches, where k is a constant. What is the value of k? All right, so that's something like this. Let's do a quick sketch. It's not great, but so you have the center here. We do the apothem in a different color. So that there is k times the square root of 3. Okay, and these are these form equilateral triangles here. First we want to figure out the length of a side. Now, regular hexagon has the same side for each side, so we do 480 divided by 6, so it's 80 inches per side, meaning that this here part of the triangle is going to be 40, and remember it's equilateral, so this is 80. So we could use the Pythagorean theorem, but we don't even really need to do that because it's an equilateral triangle, so this angle is 60 degrees here. This angle here has to be 30 because the other is 90. So we have a 30, 60, 90 right triangle. So in that case, the side opposite 60 is k times the square root of 3. That means the hypotenuse is 2k, and this side here is 1k, so k is going to be 40 inches. And if that's a little confusing, what you would want to review is special right triangles. And that's specifically the 30, 60, 90 right. Okay, problem 8. An equilateral triangle has a perimeter of 126 centimeters. The altitude of the triangle is m times the square root of 3 centimeters, where m is a constant. What is the value of m? So let's draw this out. And I want to get my color a little different. Let's do a darker color. Equilateral triangle. The perimeter is 126. So if I divide 126 by 3, I get 42. So each side is 42 centimeters long. And we have the altitude, the height here. It's a right angle there. Equilateral, so this is 30 degrees. This is 60 degrees. The altitude is m times the square root of 3. Let's do that in a different color. It's getting kind of crowded. So m times the square root of 3, because that's opposite the 60 degrees. So opposite 30 degrees, it's just going to be m. So it's going to be half of 42. 2m is going to be here, 42. So half of 42, m is going to be 21 centimeters. And that's fun with 30, 60, 90 triangles. All right, number 9. The function g is defined by g of x equals 3x squared minus 5. For which positive value of x is g of x equal to 70? So we're going to say 70 equals 3x squared minus 5. All right, we're going to solve for the two values of x and pick the positive one. So we're going to add 5 to both sides. And we get 75 here equals 3x squared. Let's just make some room up here. I'm going to write 3x squared on the left-hand side. It doesn't really matter. So divide both sides by 3. Solve for x squared. X squared equals 25. Take the principal square root because we want the positive value. So the positive square root of 25 is just 5. So the answer is going to be 5. All right, number 10. Function h is defined by h of x equals 1/4 x plus 12. For which value of x is h of x equal to 20? So again, we'll say 20 equals 1/4 x plus 12. We want to start by subtracting both sides by 12. say 8 equals 1/4 x. So to solve for x, we can multiply by the reciprocal of 1/4, which is 4/1, or just 4. 4's cancel here, so we get 1x equals 8 times 4, so x equals 32. That's it. Thank you so much for watching this video. If you haven't done so already, please take a moment to like and subscribe, as it really helps with the algorithm and motivates me to create more videos like this. I hope to see you in the next one. Bye.